Welcome, everybody. Welcome to our 2013 Summer Intern Symposium. It's my first time using this room, so the logistics have been a little challenging. Sorry for that. We're a little slow to get started. I intentionally made my opening PowerPoint very bland, so pardon the dull look. It's meant to give you a lot of excitement when you see the intern presentations because they'll be using a lot of color, nice fonts, and maybe some dynamic content. Housekeeping rules. The restrooms are out the door to the right. Go around the corridor and you should find them. For lunch, you're pretty much on your own. But you should find something at Campus Center. If you need directions, find somebody that's from here and we'll give you directions on where to go. Let me give some notes for the speakers. We have 2-minute time slots. Now, I originally sent out guidance asking for 10-minute talks with 5 minutes question and answer. But I know many of you are using your Hollings talks, which are 12 minutes, which is perfectly fine. Just realize there'll be a little bit less time for question and answer. So you can go either way. Daryl is going to be the timekeeper here. And if we know ahead of time whether you're doing a 10-minute or 12-minute talk, that'll help. And we'll give you warnings at a 6-minute mark and then a stand-up warning at 6, 3, and then a stand-up at 1. But if it's a 10-minute talk, that 3 is actually with 1 minute left, right? Or, yeah. Something like that. So tell us ahead of time what duration your talk is, and either the moderator or Daryl will get in your face and tell you to speed it up. This year we have a very large cast of presenters. We have 16 presenters from pretty much all over the country. And when I sent out an email to broadcast this, I pointed out that we have presenters from Hawaii to Maine and all points in between. In fact, we have 2 presenters from Maine, which is pretty remarkable, I think, considering our geography. We have a great diversity of topics, people working in all different line offices and parts of the agency and elsewhere. Just to give a quick plug for where I come from, we do a PYSO internship program that stands for PIF's Young Scientist Opportunity. Not only expect you to read all this, but if you go to our webpage, you can find out more about the PYSO program and what it entails. This has been ongoing since 2009. We had 1 intern. Then we had 3 in 2010. We had 3 more in 11, 3 in 12. And this year we're very fortunate. We were able to get 4 interns in 2013. And this program is now administered in the Joint Institute for Marine and Atmospheric Research at the University of Hawaii at Manoa. But the interns generally work at the NOAA facility. Again, as I said, there's a website to refer to. These are the committee members for this year. Some of them, actually, probably about half of them might be in the room helping out to run this symposium. They represent all different divisions and programs within the Pacific Islands Fisheries Science Center. For 2014, we hope to take 3 or 4 more. So for next year, if you know anyone in suitable position, please point them to our website and have them apply during February of 2014. And this is how the symposium has looked over the years. In 2010, we had 3, then we got to 6, then we got to 10, then to 16. When I plotted this up, I was pretty amazed that it looked like this. If I were trying to make up data, I probably couldn't have done a better job. It was pretty interesting to see. So this is our participation in our Summer Intern Symposium. It started in 2010. And actually, if you do what... by the way, I'm a scientist. I'm not a outreach or PR or HR person. For some reason, I've been doing this since 2010, and of all my duties, it's actually one that I enjoy the most. I get a lot of satisfaction out of it. So if we take this model as being accurate, it suggests that maybe next year we'll have 25 presenters, and in 12 years we'll be over 200. So we're going to need a bit of both. And I wanted to see who laughs at this because I figure some generations may not even know what this refers to. But this is from the movie Jaws, by the way. So anyway, when I saw how much participation there was this year, I searched around and said we need a bigger room because where we were having this in prior years was simply not cutting it. So this year we got a bigger room, and I'm guessing in the future we're going to need even a bigger room. So maybe we'll get the convention center someday. Or certainly Fort Island will have a nice conference center once NOAA is positioned over there. And as I mentioned, I've been doing this since 2010. I've had 2 interns, and they've been a lot of fun to have. And I did have a Hollings intern in 2009. And in fact, she's in the room now because she's now a coworker. So Amy Hoover back there, who's totally embarrassed, was a Hollings intern of mine in 2009. And I'm glad to say that she's a coworker at NOAA and JIMAR right now. And that's all I have. And what I would like to do is I'm going to scan the room and see if anyone from JIMAR, but I see Sam back there, so I'm going to ask Sam to say a few words on behalf of the Pacific Islands Fisheries Science Center.
Morning, everybody. Thanks for coming. As Don said, I'm the director of the Pacific Islands Fisheries Science Center. I'm a scientist too, although I'm one of those natural scientists. I'm an economist. But there is life in the non-natural sciences or the natural sciences. We're really pleased you're here. It's one of the more interesting things that as a director you get to do is to see, sort of what develops out of an internship from people who haven't been completely corrupted by the science track yet. It doesn't matter whether it's the government science or the academic science track or the corporate science track. I suppose people do that. So we're really pleased you're here, and but I will put a pitch in for paying attention to Daryl, and who's the timekeeper, because timing is important. And I would point out that the seminars at the lab, if people run over, we have ours just before lunch, Daryl gets up and leaves. So if you see Daryl leaving, that's not a good sign. So you don't want to think Daryl leaving before he's ready. Let me just also say something about NOAA. Looks like almost all the elements of NOAA employee are here. National Marine Fisheries Service is the Science Center and the regional office. Fairly obvious what we do, and you can get a sense from the talks. National Ocean Service, which is sanctuaries, monuments, and coastal services. The Weather Service, trying to make sure the weather improves and we have a little less humidity. I assume that's what the Weather Service is supposed to do. The other agencies are in charge of, things. I can't remember, it's the Satellite Service, and OAR is the other element. Research. They claim to do research, but all the rest of us do as well. And so I guess we'll find out what you've learned. I will say that although somebody pointed out this might be a little sad, my internship a number of years ago was one of the best, most memorable aspects of my life. I hope that's a positive thing for you. It's a positive thing for me. And so when you look back in a few years, go, being a boy at that internship, that was good. So we'll find out how good it was. Good luck.
Thanks, Sam. Jeff, can you say a few words on behalf of JIMAR?
Okay. Mark Meritown, I'm Jeff Hare. I'm the Deputy Director for projects in JIMAR. And Mark Merrifield is Director. He's going to try to stop in some family things that are up today. But we're really pleased that JIMAR is able to sponsor some of the interns, particularly the ISO interns. That funding comes from the center. So Sam and Mike Secchi, who's not here today, can be thanked for that. And then it comes into JIMAR, and we use that to support their internship. In addition, there's several of you that flew from neighbor islands, and so that support came from JIMAR. And we're really pleased to be able to sponsor that, because that's part of our core mission is to develop young talent. And obviously, you folks are talented. So I look forward to the presentation. So, thanks, Tom.
Thanks, Jeff. Thanks, Dan. I want to give a round of applause to Dan for being supporters of the program. Our moderator for the first session is Kelly Sage from the Coral Reef Ecosystems Division, and she'll be introducing speakers, and I'll just quickly.
Okay, as Don said, I'm Kelly Sage. I work with the Science Center's Coral Reef Ecosystems Division. We're lucky enough to have 3 interns in our division this summer. So I think we actually won out with the biggest number. And first up, we've got Grace Young. She's with the Pacific Islands Fisheries Science Center, working with Ben Richards. She's from Massachusetts Institute of Technology, and her presentation is development of a stereo video camera system for sample fish communities. Welcome, Grace.
Hi, everybody. I'm Grace. I'm going into my senior year at MIT, where I study ocean engineering with a focus on underwater robotics. I've worked on underwater robotics for pretty much my whole undergraduate career so far at MIT and at Woods Hole Oceanographic Institution. And these pictures show some of the systems I've worked on in the past for ocean exploration in the far left, and seabed oil detection and autonomous navigation. And now this summer, thanks to the Holling Scholarship Program, I got the chance to work with fisheries biologist Dr. Ben Richards on a camera system to autonomously monitor fish off the Hawaiian coast. I was working with the Pacific Islands Fisheries Science Center, and it was a perfect project for me because it combined my interest in underwater robotics with NOAA's mission to improve our understanding of the ocean ecosystems and use science to inform management decisions. And NOAA is interested in this project because it wants to ensure that the oceans stay healthy so that we have sustainable fisheries in the years to come. And there's basically 3 types of fishing here. There's shallow or reef fishing, pelagic or open ocean fishing, and bottom fishing. And today I'm focused on bottom fishing, which happens about 100 to 400 meters deep. And NOAA focuses on monitoring the most commercially important bottom fish, which are the deep 7 pictured here. There's Opakapaka, D, and Onaganaga, A. And you can see them at the grocery store. Now, there's 2 main ways NOAA and the state ensure that there's no overfishing in Hawaii. First, they have an annual catch limit. All the commercial fishermen must report their catches, and once a total allowable catch or TAC is reached in terms of pounds of fish per year, the fishing season is closed for the year. And they also have bottom fish restricted fishing areas, or berthas, which are a special kind of marine protected area where it's illegal to fish. And there's 13 berthas, and it's shown here in red on the map. And in these areas, the idea is that fish can grow without the pressures of fishing, and that the healthier, larger fish from these areas might spill over into the fished areas. And then over time, researchers can compare these areas to the fished areas to determine some of the effects of fishing on the ecosystem. And now back to robots. So the work I did this summer was built off previous work by another engineer for the Pacific Islands Fisheries Science Center. An engineer, Danny Merritt, designed this system called BotCam in 2005 to monitor the commercially important bottom fish off Hawaii in and outside those marine protected areas. And the system's been used by a lab at University of Hawaii for the past 5 years to study the abundance and size of fish. It uses stereo vision, meaning it has 2 cameras so that it can gauge depth. And the system works up to 300 meters deep without an external light source. Researchers only wanted to use ambient light because introducing more light would either scare away or attract fish and would bias the measurements. Then in between the cameras is a bait arm, and this attracts fish from a small radius around the robot to the front of the camera so they can be measured. BotCam, the concept hopefully sounds simple, but it's not really. The cameras and electronics are quite sophisticated, so the system weighed about 300 pounds, meaning it had to be deployed from a rather sizable vessel with an A-frame and hydraulics, like in the picture here. Also, at this point, the stereo cameras on that system were outdated, so the files are often low resolution, which would affect the fish species identification. And the cameras were analog, so they required an external synchronization and could sometimes drift out of sync, which affects the precision of measurements. And that's why this summer I worked on a whole new system called MOUSE, the Modular Optical Underwater Survey System. MOUSE has the same capabilities as BotCam, but it's about a third of the weight, so that it can be deployed from smaller vessels, including small fishing boats. It's also got better cameras with a higher frame rate, so we can identify fish more accurately. It's 40 frames per second, it's high resolution, and it has an Ethernet interface for data download, and this connection's more than twice as fast as the old data download system. Also, the cameras are digital, so they won't drift out of sync, and it's autonomous, meaning once it's in the water, it doesn't need humans telling it what to do, and it's modular. It's much more versatile than the BotCam system, because the core components from MOUSE can be attached onto another vehicle, such as an AUV or an ROV, or they can act on its own in the configuration on the right. Now, the core of the MOUSE system is the base bar, shown here, which contains all the electronics. I'm just going to run over each of the electronics very briefly. Probably the most important part are the cameras. And these are not normal cameras, they're ProSilica GT1920 cameras with modified software by Seabed Technologies. And we chose these cameras because they're ultra light sensitive. They'll work even 250 meters deep or 300 meters deep on a clear day where it's pretty dark in the ocean. And this is what the ocean will look like to MOUSE through these cameras. It sees black and white, because at these depths, colors are pretty saturated, and the black and white photos carry enough information to identify fish and measure their length, so the color information would be unnecessary. Also, it sees double. This is the stereo vision, and from the two images at different perspectives, it can measure the length of fish and gauge depth. And the cameras are powered by this 16-pound lithium-ion battery that can power the system for up to 8 hours. And a DVR, or digital video recorder, saves the images from the cameras. It's got two 500-gigabyte solid-state drives so that it can store images from a full day's worth of data collecting. And just to show you again, this is how it all connects together. Alone, the base bar and the electronics are 40 pounds. And then when it's acting on its own, it's enclosed in this cage for protection, and the cage by itself is 20 pounds. And then, like the BotCam system, there's a bait arm that goes in between the cameras and lines that attach the system to weights and flotation so it's neutrally buoyant. Now, as an engineer on the project, I designed the structure that surrounds the base bar, and I modeled the system in a 3D modeling program called SolidWorks, and then made the drawings for each component. And I worked with the welder and the fabrication team to get the system made. And I also talked with the people who deployed BotCam in the field for the past couple of years to see what kind of improvements they wanted to see in the new system. And I added some little details. For example, they said it would be easier if the BotCam units could stack on top of each other. So I added pegs in the corners so that they'll stack. And I got to see the project from its initial concept to its final fabrication. The picture on the right is from a pool test we did yesterday. The system is pretty much built now. The next step is going to be happening as I give my Hollings presentation in DC next week. My mentor Ben and his crew are taking botcam into the ocean and dropping it in the ocean, and then comparing the footage from mouse to botcam system. And I have a long list of people to thank. This was a big project, and I couldn't have done it without any of the people on this list, especially my mentor, Ben Richards, and Jeff Drazen, and the people in his lab at UH, including William. And also thanks to Dawn for organizing the symposium. And if anyone has questions or feedback, please reach out to me. Thank you for your attention.
All right, well, thank you very much, Grace, and we'll open it to questions. We have about 5 minutes.
I have a quick question. You said that there's a part on the robot that collects like 500 gigabytes. It can hold that much data, and then you said that it could collect all days worth of photos. So do you know how many photos are taken usually per day?
Well, we could figure it out. It takes like 40 frames per second, and then each drop, and there's 60 seconds in a minute. Each drop is like 30 minutes, 15 minutes, and then say it works for like 8 hours a day, so it's like 575,000 photos.
It's a lot.
Yeah.
It's more than your iPhone.
All right, well, thank you very much, Grace.
Thanks, Grace.
All right, next up we have Elia Knott. She's been with our division of the Coral Reef Ecosystem Division, working with Erin Looney and Dr. Bernardo Vargas Angel, who's up here today. Her project was analysis of legacy archive code diver imagery to establish trends in the benthic composition across the Pacific Islands. And she's here with us from University of Rhode Island.
So hello everyone, my name is Ilea Knotts and I am studying marine biology at the University of Rhode Island. My project fits into the NOAA mission goal of healthy oceans, and I worked in the Pacific Islands Fisheries Science Center, focused in with the Coral Reef Ecosystem Division. My mentors were Erin Looney and Bernardo Vargas Angel, and I will be presenting on the analysis of benthic cover for 2 islands in the Marianas Chain, Hagen and Mog Islands. I'll begin with an introduction to reef monitoring and give some background information on my 2 islands. Then I'll continue with my methods, results, next steps for the future, and end with a summary. So reef monitoring is conducted to document impacts of disturbances, provide understanding of changing trends, and to pass on information to management so that they can protect and conserve the reefs. They're important to monitor because they provide productivity to the ocean, habitats for juvenile fish, and they are threatened by anthropogenic and environmental factors. So long-term studies over large ranges are necessary for baseline assessments and status reports. That's why CRED sent a cruise in 2011 to perform rapid ecological assessments, or REAs, to the Mariana Islands. My project hypothesized that Hagen and Mog would exhibit variations at their own sites due to depth and location, and comparably there would be a significant difference in hard coral cover. So here's a picture of the Commonwealth of the Northern Mariana Islands where the cruise was sent. That's where Hagen and Mog are located, and as you can see, Hagen is a large landmass, about 47 kilometers squared, made up by 2 volcanoes, one active on the northern side and one dormant on the southern. Mog is a combination of 3 individual islands that is formed by a submerged volcano, and it is part of the national monument for the Mariana Islands. Therefore, it is isolated and protected with no human populations living on it. So I looked at some past studies to gain a perspective of what's already been accomplished and what is known, and they stated that wave energy had a primary forcing function on benthic habitats, and that harsh conditions such as trade winds, currents, and tropical storms could allow for sporadic reef settlement and development. So CRED sent a cruise in 2011 to perform these REAs, or Rapid Ecological Assessments, where a diver dived along two 25-meter transects, taking about 30 photos, one every 2 meters. Those photos were then uploaded into the software where I analyzed them. I used a software called Coral Point Count with Excel extensions, otherwise known as CPCE. Once in the program, the photos were split into 2 rows and 5 columns, created 10 subdivided boxes where a point was randomly placed in each. That's called stratified random design. Then, using a specific code file, as each point was viewed, a code was selected to identify the benthic habitats under each point. Some codes, as you can see in the pictures, were massive, EN for encrusting, BR for branching, which were hard corals. CCA stood for crustose coralline algae. Turf H stood for turf on hard substrate, sand, and so on. So Poggen had a total of 28 transects, and MOG had a total of 30 transects with 30 photos per transect. And the sites were selected in a stratified random design according to depth. The transects were then separated into smaller groups for analysis. Depth was separated into shallow, moderate, and deep. Exposure was exposed and non-exposed, and geographic location was north, east, southwest, and internal. Some statistical analysis that was used were t-tests for general averages and ANOVA tests for the variations on and between the islands. So getting into my results, here's a picture of the 2 islands' major functional groups averaged out. The major functional groups were hard coral, coralline algae, turf algae, and macroalgae. Even using functional groups, we can gain a lot of data. So it was from this graph that we could see MOG had a significantly higher coral coverage and lower turf coverage. And it's from here that we tried to understand the variations between the 2 islands, such as depth, exposure, and geographic location. So here is Poggen's depth results averaged out across the 28 transects. As you can see in the top right, that's the picture of Poggen that we're looking at. And with the ANOVA test, there was no significance amount between the depth ranges. However, it was noted that the moderate coral coverage was lower than the shallow and deep. And so we can assume there's a biological or environmental, physical variation going on there that wasn't observed. Location was then observed, and again, there was no significant data, but there were some general trends that we could see with descriptive analysis, like geographic location with the coral coverage increasing going around the island, north, east, south, and west. However, nothing can be said with confidence with large standard error. Then MOG was analyzed using depth, and we did see some significance. In coral cover, there was a significant more coral at the deep reefs compared to the shallow reefs. And for turf, the deep reefs had a significantly lower amount compared to shallow and moderate. The coral coverage supports the idea that wave stress can fragment coral at the shallow reef levels, pushing the pieces down to deeper levels and allowing for settlement and increased cover at lower levels. The turf coverage showed that disturbances such as wave stress allow fast colonizing turf to have a larger percentage at the disturbance levels. Then location was analyzed, and similarly to POG, there was no significance found. This could have been due to small sample size, as well as how we broke up the patterns. For exposure, the non-exposed was, as you can see in the top right corner, MOG, was the inside of the 3 individual islands of the submerged caldera, and the exposed was the outside transects. Depth was then selected because of its significance at MOG to compare both islands. First, looking at shallow reefs, there were similar levels of coral coverage. It'd be interesting to look at the other Mariana Islands to see if there's a pattern of similar coral coverage across this depth. Looking at moderate and deep depths, there was a significance in the coral as well as the turf between both islands, Mog once again having a higher percentage of coral, which supports the idea that Mog is the most coral-rich island in the Northern Marianas. So next steps for this research would be future evaluations to monitor temporal and spatial changes. It would also be interesting to determine the main variables that cause the variation, because it's important to monitor all the islands the same way. And then just to summarize my data, there was a significance in the coral and turf cover at Mog specifically, using depth as a variable, and then between Pog and Mog at the moderate and deep depths. There was an expected distinction between these islands due to the different ways that they were made up and the human and environmental influences that happen on them. This is just a snapshot of two different reefs, one pristine, which is Mog, and one not so, which was Pagan, during 2011. It provides a status report for managements to keep the reef habitats safe, and it can be used as a baseline to monitor changes due to anthropogenic and environmental impacts. I'd like to give a special thanks to the Holling Scholarship Program and all the organizations that helped me through this, the National Marine Fisheries Service, the Pacific Island Fisheries Science Center, the Coral Reef Eco Division, my mentors Aaron Looney and Bernardo Vargas Angel, Brett Schumacher, Dione Swanson, Hatsu Bailey, and Palamisa. This is my literature cited that I used to gain the perspective on what's already been accomplished. So, are there any questions? Yes.
So when you did the scoring of the samples, like one of your first slides, was that presence absence, or did you have a scale of occurrence of various characteristics?
Did I have, like, when I split them up, are you talking?
Once you looked at a point,
Mm-hmm.
was it, you were looking to see whether something was there or not there, like sand?
Oh, like my methods. Okay, for the coral point count with Excel extensions, 10 points were overlaid on the photo, and you would zoom in on that point and identify what was there. So if you saw a branching coral, you'd put BR. If you saw turf, you'd put turf. If you didn't know, lighting was bad, or it was you couldn't identify it, you don't want to guess in this research, you would put unknown. So you always knew what was there, or, unknown as you didn't know it was there. All right? Did you have? Yes?
For your statistical analysis,
Yes.
was your data normally distributed so you could use the t-test?
It was not normally distributed. That's why I had to look at the data and then normalize for multiple comparisons. So, yes. Yes?
For Pagan, did you see much volcanic material,
I did not see volcanic ash. Its last eruption was 1981, but I did notice a significant amount of turf, which could be showing that there was a disturbance on the reefs and the fast colonizing turf just took over. So we could be seeing that. Yes?
During the coral coverage at Mog, you said that there's a lot more in the deeper depths.
Mm-hmm.
Did you see a difference in species distribution too? Is it the same types of coral that you saw in the shallow regions, or did it change?
With my study, I just looked at functional groups, so I didn't get into genus or species, but I did notice a lot of encrusting, branching, massive. There was a lot of different types of functional groups, including non-sclerotinian. Anything else? All right. Well, thank you so much for your time.
One thing we wanted to do during the symposium was, after the question and answer session, was have a few words by intern mentors or mentor designee, or in absence of a mentor, we're going to have the students, the interns, say a few words about themselves. They can rate about themselves, or more appropriately, they can tell us a little bit about themselves, because they're not all from the schools they attend. They can tell us where they're from, or what they plan to do after they graduate, things like that. So unfortunately, Ben Richards left. Grace, so Grace, you can do one now to catch up, and maybe just tell us a little bit about where you've been, where you are, and where you're going, something like that. And then we'll go back to on schedule.
So, well, next week I'm going to DC for the, and then but my family's in DC too, so I'm going to stay there and then finish up my senior year. Is there? Well, I don't know what to talk about, but one exciting thing I'll be doing in October is living underwater with David Cousteau for a few weeks. Yeah, I'll probably be operating marine vehicles again, but underwater, which that means instead of from the surface or from people. Does anyone have any more questions on the system?
I only have one question.
Anyways, I have a question.
Yes.
So Botcam was big, NAS is getting smaller, and pursuing this NAS is smaller. What areas might you look at next to increase the size of your
So right now it's about 100 pounds. Ideally, it could be like 45 pounds, like a small dog or something, so it's grow it up to the size of them. But right now, I need 50 people to do that, and need the truck to transport it. But to make it smaller, like the electronics are pretty much as small. I think the next step is to work on the post-processing of the images. Right now, people inject faces from the UH. They analyze all the footage by eye, and that takes hours and hours and hours. So the next step would be to try to do some of that using machine learning and make face recognition and processing.
So if you make it lighter or smaller, if you brought those cameras close together, would it be harder to get resolution on determining the size of the fish?
Yeah, it affects the resolution. It's an auto thing theoretically with the map. It wouldn't, but it's because like the things the harder cut the eye, the better you can gauge the length of fish.
These are questions for Grace, and we have about 3 minutes for Elia's mentor, Dr. Bernardo Vargas and Health, to say a few things about it.
Yes, thank you. This is the third time we've also marketing folks at home smaller, and we always have wonderful experiences with marketing section. And Leah did an outstanding job with the analysis of the images, but not only that, she integrated with our team pretty nicely, and it makes the things that we see her at the park. We'd like her to stay and continue working with us. She'll be like the 11th participating in the national skills presentations next week, and then she'll go back to the University of Rhode Island to finish her last semester. After that, she's interested in getting some real world experience, getting a job, and eventually maybe in a couple of years or so getting a master's in marine biology and marine ecology. So we wish her all the best, and hopefully she can stay in touch, or we can stay in touch with her, and who knows, perhaps in the future, join us to work together. Thanks again.
Thanks.
Okay, next up is another one of the interns. You chose me appropriately for session 1. Carl Lindbergh was at our division working with Jason Asher. Carl's from Eckerd College, and his presentation title is Analysis of Data from Remote Underwater Video Surveys.
Okay, well, you pretty much said my name's Carl Lindbergh. I worked with Jake Asher this summer analyzing stereo video for brief assemblages of fish. So as a basic outline for what I'm going to do today, first off I'm going to talk about what are stereo grubs and rubs and why we're using them to monitor monitor fish. I'm going to talk about some basic product goals we hope to accomplish through these surveys. We'll talk about overall steps and processing the video and some basic training I received. And then I'll show some really preliminary data we have. I haven't actually processed that many videos because I haven't been doing this work for that long. And then I'll talk overall pros and cons, and I'll wrap things up and have a question and answers session. So for our surveys, we used baited remote underwater video surveys and also unbaited remote underwater video surveys, RUBS and RUBS respectively. And that sounds like a lot, but really the concept is pretty simple. Basically, you take a machine that's made out of an aluminum frame, and it's deployed off the side of a boat, and it has 2 cameras on it, and the cameras record anything they see, and later on we go through and we process the video and we identify the fish to get an idea of what's down there. In the case of BRUVs, you can see this right here is an arm that features a little mesh bag with some bait in it. It was typically sardines, and that would attract certain fish in to get a better idea of what could be down there. There are a lot of different uses for BRUVs and RUBs today, and mainly it's just an alternative to stationary point count surveys, which are done by divers where they follow a transect line in a certain area and see what fish are around them. So this map shows where our current study site is. Right now it only fits in this small area of the main Hawaiian Islands, but it will later continue to have some of the northwestern Hawaiian Islands in the fall. And this is really great for our work because it has unpopulated and populated areas for people. And one of our questions is wondering if human interaction has affected the way mobile predators might behave. Specifically, during these diver-based surveys, they're not showing up very frequently. So we're wondering if perhaps through pressures like fishing, maybe these fish are trying to avoid humans. So by using stereo videos, we hope to see potentially a difference in results of finding them. And then we're comparing some basic measurement results between video surveys versus the diver-based surveys. And this includes things like length-based measurements, number of fish seen, species identified, and then some habitat characteristics. And we'll also be comparing these features between the baited and unbaited video surveys. And as far as our videos go, they were typically 60 minutes long with some 20-minute long videos. And we're trying to figure out the optimal soak time for how long the videos should be under. And we've divided 60-minute videos into 20-minute periods to help us figure out what can give us the best representation of what's down there. And then finally, some of these videos were deployed off of mesophotic reef systems, which we've classified as reef systems from 30 to 100 meters, as well as shallow water reef systems, which are from 0 to 30 meters. So we'd like to compare the species assemblages in both areas. So as far as my training goes, I had to learn around 130 species, pretty much right from the start of my internship. And so I used a lot of really great resources. I read John Randall and John Hoover both have great books for identifying fish, and they give good descriptions. In addition, I used Kyoki Stender's website, marinelifephotography.com, and that provided a lot of photos if I ever needed additional resources. But probably the most important thing I did for practicing was going through a set of calibration videos. And basically, anyone that's going to process video has to go through a set of 4 fairly challenging videos that have been processed by several people before. And the idea here is if your numbers look a little different, if you're not seeing the same fish, then you just need a little bit more training, which isn't a big deal. And this helps make sure that all the processors can be really qualified to continue with this work. As far as actually processing the video goes, we use a program called Event Measure. And we load up we load up the video files onto Event Measure, and right when when the BRUV or RUV system hits the ground, we set up the video into 20-minute periods to help with the soak time question. And as well, we take some basic habitat notes, such as what habitat type it is, what's the depth, things of that nature. And so as a preface to it, actually processing the video, if you think about looking at a camera, you're only seeing a specific area. And if fish move around, obviously, so if you see one individual of a certain species swim into the footage and it's there at 2 minutes, and then the next second it's gone, and then you see another individual of the same species show up at, say, 5 minutes, well, does that mean there's 2 individuals of that species in the area, or is there 1? Well, there's no exact way to know this, so we use a measure called max n, which means that we look for anytime we think we see the highest number of individuals of the same species on a single frame for a period at the same time, then we would mark each fish. I know that probably sounds like a lot to handle, but basically, if you see something like this, where there's like over 100 fish, then there's a good chance that could be the max n. In some cases, it's just 1, actually, but this max n basically gives us a conservative estimate as to the number of fish. So these are some very, very preliminary results comparing SBC, again, diver-based surveys, to that of the unbaited stereo video surveys. You can see the sample size is 12, and that's just because we've only explored 12 sites in Maui so far. And I've done a few in the other islands, but I think the majority of my project will be based on Maui. So the y-axis contains the mean number of fish per site, and the x-axis has the species of concern, which are determined by the Fisheries Research and Monitoring Division. And so if you look, 6 out of 10 of the species of concern are showing up more frequently on the SPC diver-based surveys than they are with the stereo video surveys, which is to be expected. But these numbers might change over time. And if you're wondering why the error bars are so high for these 2 individual species, that's because, again, a low sample size, and in some of these videos we're seeing, potentially over 100 fish of the same species. In other cases we're seeing 0, so a higher sample size should adjust this. Really quickly, as far as the mesophotic assemblages go, the mean numbers, the different number of species we're seeing definitely varies from the shallow water species. Again, you're seeing these species of concern here, and this graph is basically just to show that some of the species are present and some aren't present. Mesophotic research is really important because there's not much work done here as of yet, so we'd like to find out what's down there. And divers aren't really capable of going to some of these depths. So. Oh, and this species here, Nasohexacanthus, that's a species that once the video landed, in one video we had 120 individuals immediately, so that's affected the error bar. As far as mobile predators go, I suppose I might have messed up on this one earlier. Mobile predators seem to be detected more frequently on stereo video work than SPC dives. Basically, SPC dives barely see them. So with these, we're finding that some of these species, especially these 2, they're encountered in almost every single stereo video survey. So this could be a potential benefit of using stereo videos in the future. But overall, we're finding out that SPC dives are encountering a higher number of species at each site, which again is to be expected. So as far as pros go for using stereo videos, it's really easy to train people. It's cost effective. It can go to deep depths. You can get very accurate length measurements, and you have a permanent library of the results. The cons perhaps are more severe. It takes a really, really long time to process these videos. Things like visibility can affect them. You need at least 3 visibility. Even with that, lighting and coloration can really affect it. And then one of the biggest problems is the bait plume with grubs, you don't know how far the scent of the bait can travel and how certain fish will react. And also, with a max N, you're getting a really conservative estimate, which can throw off management efforts. So overall, no matter what survey method you use for measuring reefs, there are always going to be some biases associated with it. And perhaps the best way to avoid this is to use a combination of different survey methods or pick a survey method that's better suited for your question. And I think the best uses for stereo video surveys in the future would be either for monitoring mobile predators like sharks and jacks, or also for measuring reef assemblages at mesophotic reef systems. I'd like to thank Jake Asher. He's a great mentor so far, as well as the Coral Reef Ecosystem Division and PIFSC, and Don for inviting us all out here today. Thank you. Do you guys have any questions? Yes?
Why did you expect there to be a higher diversity of species on the divers surveys than on the video surveys?
Well, previous literature has basically shown that more species are encountered with diver-based surveys. Things like cryptic species, really small species are, I mean, you can see them on stereo videos, but I think we're missing out on the actual detection of them. But grubs can help with mobile predator detection, so, I mean, you're seeing different sets of species, so that's why a combination of them is so good. Yeah.
I was wondering how you think that the image processing could be made faster.
That's a good question. I think in your case, I noticed you guys don't have any color, and at least with me, some of these reef fish are really, the colors are the identifying signal. So that for me would be something to improve with BotCam. With stereo videos, I don't know. It just takes a very long time to process. I don't know if potentially a better program could improve this, or just more studies on the bait plume I think would help as well, because it would help eliminate some of the biases associated with it. Yes?
Yeah, so how long does it take to process
Yeah, that's a great question. Some of the videos would land on Halimeda beds, and those ones specifically, there'd be really low species diversity, and so those ones could take anywhere, like if it's an hour-long video, it might take me 2 hours to process, whereas some of these reef systems can take, an hour-long video can take me about a day to process. But it honestly, it varies greatly. So normally what happens is I'll start one video on one day. It'll usually finish up, if I start at 8 o'clock, I'll usually be done with it by maybe 1 o'clock. And then I'll start another one, and it'll kind of go on to the next day. So I don't know, maybe about 4 hours. Mm-hmm.
So find the video to be easier than to interpret than the static?
Well, the program we use, Event Measure, it's really helpful. It can zoom in, it can slow down to half speed, and when you actually have to go in to mark the species, you pause the video and exit out and mark everything. But I think with some of the harder species that I can't, immediately identify as they swim by, I would have to pause the video and zoom in. So it depends on the species, but with especially the harder to identify species, the pausing the static image was helpful. Anything else?
Okay, then we'd like Jake Asher to stand up and say a couple words about Coral.
My name is Jake Asher. I work with Grant, and this is the first time we've hosted this opportunity intern. Carl came in the beginning of June, spent the first several weeks with us, primarily studying reef fish, reading a number of the different manuscripts, looking at getting an unabated remote underwater video station literature, went through a series of tests, went to the aquarium, we went out with the SBC team, diver SBC team, to actually compare against what the divers were seeing versus what he would potentially be able to identify from the surface, and then has primarily been working on processing stereo video for the last month. We are incredibly lucky to have him for another month, so he's just about half to 2/3 of the way through. So it's primarily going to be focused on the southern shore of Maui. This is the summer after his sophomore year, and he's thinking about a number of different places he can go with marine science. Could be coral reefs, could be working up in Alaska to go with the observer program up there. So again, we're very pleased with the progress that he's made thus far, and looking forward to work with him over the course of the next 2 weeks. So, thanks a lot.
Up next, another one of our interns, Corey McClanahan. She's a PISO intern, and she worked with our benthic habitat mapping group, Dr. John Rooney, from Hawaii Pacific, and her presentation is Video Database for Mesophotic Corals.
Hi, Corey. I'm working with John Rooney, which he's getting ready for a cruise right now, so he will not be here today. My project is kind of similar to the last one, except for I'm working with all still images from a toad system and with corals instead, all under depths below 30 meters. So my main project was working on previous research that came from American Samoa that was done in 2002 and 2012, and I am focusing on the ecosystems that are light dependent but under the traditional 30-meter mark that was previously thought to be the max depth for such communities. And these have not really been any subject to previous monitoring, so this is pretty new. I also worked previously at Oceanic Institute working on the Leptoceras and measuring things like that around this island specifically. So I'm working with the Pacific Islands Benthic Habitat Mapping Center. So most of my trailer mates are getting ready for the cruise as well, so they're not here today. And my depth focus was a minimum depth of 30 meters, and our max depth was 178. So I basically am compiling all these still photos, creating a database from scratch. Basically my first day they handed me a huge file full of 15,000 images and said, here you go, make a database, which I had never done before, so access was a very interesting experience for me. Yeah. So I'm focusing on these 2 islands there, and the 2012 is the main one that I was focusing on. It had the most images available, and it was the most recent. 2002 images had already been subject to some kind of exposure to a database system, so I'm mostly focusing on these smaller islands. So this is TOAD, the TOAD Optical Assessment Device. Basically, they took this off of a 40-foot vessel in American Samoa and ran it down. I believe it was 65 different sleds that they went down and did dives with. So they covered about 31 kilometers of the seafloor. So there's a lot of pictures going along with that. It has a downward-facing still camera, forward-facing video camera, depth sensor, sonar altimeter, and a whole bunch of other instruments that the benthic team is using, but I personally do not use the data from. And these are images of the 2 islands that I'm specifically working with. The little marks on there are the actual areas that the toad was deployed, so you can kind of see that it was spread over around the entire island, so that way it's kind of a broad spectrum of where these diverse ecosystems are underneath the 30-meter mark. So once these images were taken off of the toad, they came to me, and any unusable ones, so any ones that were blank, nothing was seen, there was a lot of blurry ones. There were even some where fish were right up in the camera and it was kind of blocking the whole thing. So any of the unusable ones were thrown out immediately. And the grid overlay here was thrown on for identification purpose so that a grid number could be assigned to each one, so it could be easier to say, okay, instead of this this coral here is this one. You can say, okay, grid 1 has this species exactly in it. And that was done using the ImageJ program, which is just a free online program that's pretty helpful. And then the images, once the grid was laid on, was made available onto the FTP server so that anyone outside of the NOAA division that doesn't have access to our own personal servers can go ahead and get access to them. And the numbering system was laid on also to make it easier, and that was applied to all of the 15,000 images, so that took a little while. And this is just a basic screenshot of my database that I have made. So on the image area up there is a hyperlink to the FTP server. So once they click on that, it'll take them to the exact image. And then the grid reference system makes it a little bit easier. For example, behind the numbers is actually one of the images that we threw out. So there was plenty of those that looked like that where there was nothing that could really be seen. So each grid is assigned the family, genus, and species of the coral that's in that. And then there's also a % confidence that is assigned to each one on how well, because these images are from further away. It's not like you can measure the Septocostae, the fossa, or anything like that. It's all very, very distant and sometimes blurry and a little bit difficult. So basically what I do is I tentatively identify the best of my abilities, and then I send it off to taxonomic experts that are kind of all over the place, and they get back to me with, they fill in the % confidence, and then if there's any changes that are made, they let me know which ones are changed, which ones were correct, so that way I can get a better understanding of how I'm progressing through my identifications. So I have 3 taxonomists that I'm working with. Douglas Fenner, he works with the Coral Reef Monitoring Society within the Department of Marine and Wildlife Resources in American Samoa. So he is actually a great help, so he's seen these on a daily basis, so he has a better idea more than any of the other taxonomic people, so he's kind of like our main guy. The second is Zena Dennison. She's with the Australia Coral Reef Society. And then Tom Bridge, he's also working out of Australia as well. So they're kind of the backup since they're a little bit further away from this area. And then I've also been using Baran's books, The Corals of the World, which have been pretty much my Bible for the past 2 months because there's so many different things that I've been learning about the different species. And looking forward from here, I am just now going through the database. So the database took me the longest time since I had never used Access before or anything quite like it. So now that I'm finally past that point, I've been working on identification. So right now I only have about 200 images actually identified, but I still have 3 weeks left, so I'm hoping to get a good chunk of, definitely not all 15,000, but a good chunk of that. So once photo identification is completed, either by me or someone else after I'm done with my internship, they also have the front-facing video camera to use, which is like the last person who presented, going through and taking frame grabs from that and going through that. And then the database foundation can be used for other species, other islands. You know, it doesn't have to strictly be used for corals. It can be used for pretty much any kind of image that documents a community area. And then also, I know that I talked to John about potentially another intern next summer coming in and working on making an actual benthic habitat map, showing where each species is dominant and where they are lying in these mesophotic areas. And I'm also working on a key for American Samoa to make it a little bit easier for anyone else that is doing this kind of research, because there's not really a specific key out there for species that are actually in American Samoa. And this is mostly relevant because recently 66 coral species were proposed for listing under the Endangered Species Act, 59 of which were here in the Pacific Ocean. 7 were listed for endangered, 52 as threatened, and I've only gone through, like I said, a couple hundred images, but already there has been some positively identified ones as under threatened, no endangered yet, so this could potentially help to get that rolling a little bit better and proposal being pushed through. And then my acknowledgments, John Rooney, which, like I said, is not here. He's been incredible. Viv, who she's no longer with NOAA anymore, but she was in my trailer for a while, and she helped me a lot with the database. I have the IT guys definitely were a huge help. Kevin Trick, he was, what took me hours to fix took him literally 30 seconds, so that was fun. And then the entire Coral Reef Ecosystem Division staff, they were super friendly, very welcoming, made me feel right at home. So definitely going to miss everybody once I am done in the next couple weeks. It'll be very sad. But yeah, so I have a couple more weeks to get going and get as many identifications done. Any questions? Thanks, Corey. Any questions for Corey?
Yeah, you mentioned that you had you only went through a couple hundred images or so.
Mm-hmm.
And you mentioned you only found around 66 endangered species of coral. About how many other species did you identify?
Well, no, the 66 are being proposed by NOAA, not just, that's the entire Pacific region. So that's that was presented, I think, earlier this year for listing. So I didn't find 66 each. Right now, I have noticed that most of the images, since they're from the same island, have the same handful of the number of species. So once I got positive identifications, like, okay, this one's repeating in every image. I would say closer to about 30 species altogether, with about 5 that are repeated in almost every single image. So it makes it a little bit easier. Every now and then you get one that's kind of out there different, and those are usually the ones that are either threatened or not new to the area, but mostly rare.
So, standard question, how long did it take to go through the
At first, I will admit, because I had never done any kind of identification before, what I did in my last research with OI was just measuring septicostic measurements, distance in the faucet diameter, things like that. So I wasn't working with any kind of identification. So my first images where, like I said, if some would have 2 corals in, some would have the entire image full. So I would say one image at first would take me a solid hour, because I'd have to flip page by page through Brown's book until something looked similar or decently close. But now it can be anywhere between, 10, 15 minutes for the dense pictures.
And so what comes out of this would be a photo key then, too.
Yeah, also.
And so maybe I missed the other part, but you highlight the dominant coral grid cell.
Well, the grid is set up to where, with the distance that the code is from the bottom, where there usually is not more than one actual coral in a grid. It's usually filling one grid or another grid as well. So if there is one that is filling or half, if it's 2 in one grid, there's a little note section where you say, okay, grid number 2, it's the top half or the bottom half. Make it a little bit easier so that way they can know which one I'm referring to.
So you have both, so you know both species.
Yeah.
It seems, well, from what I know of the toad, you mentioned that you might be able to use this for benthic habitat.
Mm-hmm.
And in order to do that, you would have some kind of you would need some kind of estimate of cover.
Mm-hmm.
And these photos, I think, are taken at multiple depths.
Yeah.
And so, or I should say, depths from the bottom.
Yes.
So how are you getting an estimate of coverage, not just,
Mm-hmm.
I say identifying species, but
Yeah.
how do you get an estimate of coverage?
I do not have any kind of coverage for, I haven't even looked at coverage at all. It's strictly just identification, and they haven't really said where they want to go with this database, what they want to do with it. It's very preliminary. They said that they haven't really done much like it before. So what they're going to do with it, John had mentioned he wants to try to do a benthic map, but he said it'd also be difficult because of there's GPS on there, but like you said, it's going to be hard when you have multiple distances, and it's going to be hard to put it all into one ratio. So I'm not sure how he would do that. I'm sure Jeremy or one of the people who are more experienced could totally figure that out. But as far as me, I'm just strictly identification and database.
What were the dominant corals that you saw in the mesozoic zone there?
Right now, most of our stuff we're sticking strictly to the species part. A lot have been thrown out because it's just too far away to tell which ones, because there's so many so similar. Right now, the entire opposite of the Acroportic family, Pavona is a good one. Pavona varians is a good one. There's also a lot of, which I don't document the coralline algae, but that is very, very dominant in pretty much every picture. I would say over half of the image is that. So I've mentioned to John that maybe we should document that because it is such a high presence. But I noticed that's probably the number 1 that we found.
Okay. Thank you, Corey. And as she mentioned, her mentor, John Rooney, couldn't be here today, so one of the team members, Russell Watkins, is going to say a few words about Corey.
Yeah, well, so actually, I like the idea, as opposed to everybody listening to me, Corey telling us a little bit. I will say, she's worked really hard. She's really doing a good job, but, you know.
Okay, yeah.
Where are you going?
Leave it on me. I'm not sure where I'm going. I'm in my last year at HPU. I actually transferred in from University of West Florida, which kind of set me back a little bit because a lot of my stuff didn't transfer quite well. So I do love it here. I'm totally in love with the island, and I would like to stay. So I've been looking into UH's grad program for once I graduate. I also just got offered a job for the entire winter break in Costa Rica, working at a big cat sanctuary, which is totally different than anything I've ever done. So I know it's totally not marine biology related, but I figured something like that you can't really pass up. So I'll be there for 2.5 months. I have to get all my rabies shots and everything. So that'll be fun. And so I'm not really sure where I want to move as far as my degree and my master's. I'm more on like the I'm really into like physiology, ecology, things like that. So I'm really not sure. I'm just kind of seeing what's out there and sampling here and there, seeing what fits my style. But I have been kind of focusing more on corals just because that's what I have experience in. Not necessarily my only interest, though. So pretty much anything that gets me out in the water, I'm okay with. Great. Thank you, Corey.
So on the subject of employment, so you folks are obviously working on your university degrees. Likely many of you are going to pursue higher degrees. But as you go through these endeavors, keep in touch with your mentor. And if you're ever interested in employment, a lot of the employment circumstances in the Pacific Islands Fisheries Science Center are through JIMAR. And JIMAR employment is through RCUH. So if you keep checking the RCUH website for employment opportunities, there may be something there in the future. So we're always looking, there's always a flux of jobs going through RCUH, particularly in the quality division.
Thanks, Jeff. All right, our last presenter for session 1, William Truong, who participated in one of the recent cruises off the Big Island with the Science Center's Ecosystems and Oceanography Division. His mentor was Jeff Drazen and Phoebe Woodworth-Jeffcoats, who's from University of Hawaii, Manoa, and his presentation is analysis of midwater trawl samples from Leeward, Hawaii.
And so, hi, yeah, my name is William, and I was going to talk about the trawling we did off of Leeward, Hawaii, and this is actually my first symposium talk, so it should be fun. All right, so here's a brief overview of what I'll be going over today. I'll be talking about micronecton, which is what we were trawling for, and then I'll go over a little bit of our methods, how we went about catching all the little guys, and the process of going back to the lab and counting them and preserving them. And then I thought I'd end it with just a little of our current progress. So, all right. So what are micronecton? Micronecton are basically any organism in the ocean column that are between 2 centimeters and 10 centimeters. So, yeah, so it can range from anything from fish to crustaceans to squids, and so yeah, and probably the next question you're asking is, why should we care? And basically, micronecton, like any animal, I would think in the animal kingdom, is a part of a food chain or a food web in case of the ocean. So basically, what micronecton feed are the higher trophic fishes like tunas and billfishes that our fisheries just love to catch. And so basically understanding the abundances and diversities and what affects them is kind of important for conservations and fishery management in order to better conserve those types of fishes. And my own general interest in the topic, I've always loved studying fish. And so I have to thank Dr. Drazen for allowing me to help out in his lab. So pretty cool. Going on to methods, all trawling that I participated in was aboard the Oscar Elton City, the NOAA ship, down at Snug Harbor, I think. And all trawling was done from 0 to 200 meters using a cob trawl, which is basically just this large mesh net that leads back into this little knapsack called a cod end. And you can see from the picture we're actually emptying the cod end into a little aluminum bucket there. And all trawls were done at night, so in order to best make use of the micronecton's tendency to undergo diel vertical migration. And for those of you who may not know what diel vertical migration is, it's basically a migratory event that occurs for most planktonic creatures and micronecton. Basically, at night, all the micronecton come up from deep water to shallower water, and then during the daytime, they go back to deeper water to avoid predation and whatnot. So in order to best make use of this, we would trawl at night when they're at shallower waters and easier to catch. And all trawling was done at 6 different locations off of Leeward, Hawaii, at 2 trawls per location for a total of 12 trawls. And some other tools we used aboard the ship was acoustic detection, or a type of sonar, which allowed us to scan the ocean layers to try find where there are most abundant micronecton so that we can catch as many as possible. We used an EK60 acoustic device, which is a little bit beyond my comprehension. I didn't actually deal with the acoustics, but I'm very thankful for it did. And then once everything was caught aboard the ship, we would sort them into 7 broad categories, because we obviously can't sort them to like family or species level while aboard the ship. And then once they're all sorted, we stored them, stuffed them into plastic bags into the minus 20 degrees Celsius freezer that they had aboard the ship. And here's just some preliminary data that we had one of the students make up who was aboard the ship, thanks to Johanna Wren. And here I thought it would make a good comparison to look at the trawls that were done in 2011 to the ones that were done in 2013. The sizes of the pie charts are based on the general weight of each catch. So you can see we're trying to compare the spatial, how space towards the island affects the trawls. So like you can see how like some abundances are a lot smaller, farther away from land. So it's just some stuff we're looking at. Like this is really early data. So we're hoping to maybe gather together and get it all together. Yeah. And next I thought I'd just go over briefly of what we caught. I obviously can't go into too much detail, or else I'll be here for a lot longer than 10 minutes. So yeah. So first I thought off with some mesopelagic fish. Most of these fish are actually called myctophids, and actually myctophids make up like a super large percentage of what we catch in terms of fish. Like these guys take up almost like 90% of everything we catch in the fishes. Basically, they're pretty easy to identify. Most of these fish are actually skinned, so they sort of have like a dark pinkish color. But when they have all their scales, they're actually like almost pitch black color with photophores on their underbelly. So yeah, they're pretty cool. The next are the crustaceans, and basically these guys are all the shrimps. I think personally they're one of the easiest things to identify for me back in the lab, because they're pretty easy to spot, whether they have pincers or you look at their shells, at their pleuras, see if they overlap. And I thought that's a cool picture on the top left of a lobster larvae called a phylosome. So here. Next are the squids. Squids are really awesome to catch because there's so much variety. Like they can range from the size of your fingernail to as long as your arm. And I have to thank Dr. Richard Young for coming by the lab and actually helping me out with identifying these guys, because yeah, they're pretty hard to sort of differentiate. But what you have to look for is their photophores, whether their tentacles have spikes, and it can get a little complicated. And then there's the gelatinous zooplankton, and there's really not much to say about these guys other than they're jellyfish, they're gelatinous, and they're pretty easy to tell apart just from the pictures. From the salps and pyrosomes. And then there's the shorefish. Our lab doesn't necessarily deal with too many shorefish. We actually had another grad student there who was analyzing and modeling these guys. But you can easily tell them apart from the meat. These are blackfish due to their really colorful coloration, and usually their larvae are white or transparent. So yeah, those are really nice to look at. And then there's the dragonfish, which personally, whenever I think of micronecton, I usually think of these guys because they're usually really cool. You can usually they're very distinctive from their eel-like bodies and their fang-like teeth, and many of them have those long lures coming down their chins. And then there's all the leftovers, which are basically mostly krill in this picture. Basically anything that fell under 2 centimeters in length, we just all tossed together in a plastic bag and called it miscellaneous. And I don't look forward to sorting these. And now going back to the lab, basically all the specimens I look at are sorted by family, and then they're weighed, and then of course they're counted, and then I stuff them in a jar and fill it with 10% formalin to preserve them. And then all data are recorded, of course, go in my notebook and on an Excel sheet, which then will eventually be added to my mentor Jeff Drazen's Excel sheet, which has probably like years of data on it. So everything I'm doing here is just like one little cog in a much bigger machine. And I just thought I'd throw in some pictures of my lab. And the top left picture is actually one completed trawl with all the crustaceans and all the fishes. And then I work under a hood so that our lab doesn't smell like fish and formalin. And then there's just a little tray of gelatinous that I was sorting at the time. And then on the bottom right, actually jars full of mesopelagic fishes. Most of them are all myctophids. And then I thought I'd talk about a little bit about the error we encountered. From that picture there, we had some damage to the cod ends, which is actually caused by cookie cutter sharks, which we would sometimes catch inside the cod end, and they try to eat their way out. And then basically, when they make a hole like that, when the bag is 200 meters down, like everything inside just comes out. So it's really unfortunate. And then there's unidentifiable species, which are just our specimens, which is basically any specimen we see that became too damaged to really identify. So we just count them too and weigh them, and just in case, and add it to our Excel sheet. And lastly, I just thought I'd throw up some data from one trawl. And as you can see, this is actually just the fish from the trawl. So you can see the large majority is actually that myctophid fish I mentioned earlier. And this is just an average trawl. It actually only had 600 myctophids. The largest one we had over 1,400 myctophids. So you can just imagine me under the hood just picking out 1,400 myctophids. And, so yeah, that was fun. And I just want to thank everyone in the lab, especially Dr. Jeff Drazen for allowing me to help out, and everyone else mentioned there. And I'm running out of time, so any questions?
Are you seeing a high number of bycatch at all in this, especially the macronecton? And if you were, do you think there's something technologically that can be changed with the
Yeah, we actually did catch a few large things. Like we caught a couple of remoras and some other fish that we weren't used to catching. But usually the cod end is usually large enough to eliminate large bycatch, because usually large fish can just swim out of the way of the net because we're not exactly going at an explosive speed. But in terms of eliminating it as bycatch, I don't think it's really a large priority because it's not really a large problem. And usually it's pretty cool when you catch something big.
Did you record any data on those fish that you do catch as bycatch at all, or you kind of just fish into this stuff?
Well, yeah, of course we count them because they're still from the same water column that we're trawling. So even if they're not micronecton, it's still good data to have. And some guys like to sample their tissue and just see their genetics and stuff like that. Yeah.
So along those lines, is there any provision made for species that may have escaped the net? In other words, the shape of the bag or whatever, or the speed that the critters can move, get out of the way? Is there any parameterization or any method made to sort of capture that?
Yeah, that's a good question. That's actually really hard to sort of calculate because especially the squids, which are like really smart, they can usually get out of the way of the net. So that'd actually be a really good question to ask my mentor because I don't know too much about that kind of stuff, but yeah, I would imagine that would be a problem. But we do analyze the volume of water that we trawl, and then we can sort of like analyze like how much of the ocean we're doing. And I don't know if that's relevant. I'm bad with it.
Okay, is Jeff Drake in here?
Phoebe's here.
Phoebe's going to say a couple words about Lynn.
Okay, so Jeff Drazen has been traveling almost the whole time doing his work, but he's doing a great job. Lynn went on the cruise with us in the south of our week in Kona, so got to really get in there and see the fish. So that was great. The senior at UH, I think he's still kind of trying to decide where he wants to go next and what he wants to do. I know he's working on doing more work with Seymour, but if you have any other plans to think about some of them. But we really appreciate his help with the trawl work. We don't really have the people in our division to sort the fish to this level, and William's doing a great job with that.
So that brings us to break, and right on time, I think.
Great timing by the speakers and moderator. Thanks, Kelly and Joe. 15-minute break. There's coffee and cookies over there. Feel free to mingle or leave the room, but please be back in 15 minutes. We're starting our second session of the symposium, and our first speaker is Ms. Ariana Snow, who will be telling us about the work with high school students.
All right. Well, good morning, everybody. Thanks for coming out here. Like he said, my name is Ariana Snow, and I am an upcoming senior at Oregon State University this year. And I worked with Dr. Malia Rivera under Alan Tom in the Resilient Coastal Communities Goal with Hawaii Institute of Marine Biology on a summer education program to increase science literacy in Hawaii's local high school students. So my internship this summer had two parts to it. The first and the most important one was a summer experience in marine science for local high school students, but I've also been spending a lot of time in a genetics laboratory characterizing some genes in the opakapaka, or the pink snapper. And for the interest of time today, I'm just going to be talking about the summer experiences in marine science program, but if you have any questions afterwards about my work with opakapaka, I would be happy to talk about that. So the summer experiences program took place on Moku'alo'e, or Coconut Island in Kaneohe Bay, here on Oahu, which is a really unique setting that is currently operated by the Hawaii Institute of Biology. And a lot of the university research goes on this island. There's a good consortium of scientists that are working there. So it's been a really unique and positive experience working on the island, and taking a boat taxi to work every day is something I can't really complain about. So as many of us know, coral reef ecosystems around the world are extremely diverse, extremely important, and are a large source of biodiversity, and also support our coastal resources. But unfortunately, as many of us also know, coral reefs around the world are being lost due to human activities and are experiencing things like phase shifts to algal-dominated systems. But here in Hawaii, we have some of the more resilient reefs in the world, and a lot of them are gorgeous, and going out diving and snorkeling is one of the most important ecotourism economies on the island. But unfortunately, that also means that human impacts here on the island are also increasing, leading to events like disease outbreak and bleaching in some of our corals. So in order to keep these coral reefs vibrant and beautiful and healthy, it's extremely important to not only study the biological processes that go on the reefs, but to also educate the coastal communities on successful management practices and conservation efforts. And it was under that pretense that HIMV developed this summer education program. And the goal of the program is to increase science literacy in local Title I public high school students, primarily to increase their interest in marine science. as Hawaii high school students are underrepresented in that demographic, especially here at UH. So 20 students were interviewed and selected to take part in this program. I serve as a mentor or an instructor along with 9 of my colleagues to instruct the students throughout 5 weeks in the summer, eventually ending in developing their own research projects. So we divided the program into 8 academic lessons. They included coral reef ecology, coral reef monitoring, ocean acidification, marine bioacoustics, sea urchin fertilization, marine aquaculture, and then developing their own science research projects. And I'm going to highlight the ones in red today for the interest of time. So the first lesson that we talked about with the students was coral reef ecology. And that was kind of immersing them into this environment, into this academic intensive program, and orienting them to the ecosystem that they would be working in for 5 weeks on Moku'alo'e. So the first day we did a reef snorkel where the instructors took the students out. We worked on identifying different species and just kind of immersing them into this beautiful environment that they now had access to every day. And then day 2 we got into the science part of it. So I gave a lecture on some reef monitoring research that I've done in the past in the Caribbean. And I designed an activity where they did some field practice transects out on the lawn, practicing taking photo quadrats. And then we moved that exercise out in the field onto the reef itself. And then we did some data analysis with coral point count, as we've heard about earlier with one of the earlier presentations. So this is some of the pictures of that coral reef ecology exercise. We uploaded the data into CPC, and that took several hours to have the students process the data and then talk about what it meant to have benthic percent cover and analyzing the composition of species at different sites on the island where we sampled. And as you can see from the pictures, we had the students take photo quadrats. As they were snorkeling, it was challenging to organize the students to take those photo quadrats, but of course, while we were doing this, we stressed the importance of being respectful of the reef and doing things in a very scientific manner. The next lesson, excuse me, that I'll highlight was the ocean acidification exercise. We did a lecture on ocean acidification, applying different aspects of biology and chemistry that we could see on a small sample size at Moku'alo'e to apply to a global perspective, especially stressing the importance of climate change and that effect on coral reefs. So we had the students measure pH and calcium concentration in an experiment that they designed with bubbling CO2 into controlled tanks. They developed hypotheses and experimental plan to test the dissolution of different shells in coral skeletons and see the effects of that in a microcosm environment. So one way that we analyzed student success or comprehension throughout the program was doing pre- and post-tests after each lesson. So this is an example of one of those questions from the tests. The question was, why do scientists think ocean acidification will be bad for corals? Essentially, our goals with establishing these tests was to help them apply what they learned to a global coral reef ecology perspective, stressing conservation and successful management of those ecosystems. So on the y-axis, we have the percent score that they got on those tests, and on the x-axis, we have the correct answers with the correct one outlined in red. The pre-tests are in blue, and the post-tests are in orange. And as you can see from the graph, there was an obvious increase in responses to the correct answer after the lesson. So the next topic that we covered that took a lot of time was covering the scientific method. So this was something that was completely new to most of these students who were just starting their either sophomore or junior year in high school. And what we did was take them through a lecture describing what the scientific method is, how you write a scientific paper, how you go through experimental design and developing hypotheses. And this was all in preparation for them to develop their own team independent research projects. And what they ended up doing was splitting up into small groups, each with a mentor assigned to each group. My group studied the biodiversity of sea urchins, for example. And what we did was help them develop an experimental plan and work with background research of primary literature to kind of talk about what we could study in a reasonable amount of time, which was 2 weeks. They did field data collection over the course of a week. Most of the data collection took place on Moku'alo'e, but we also traveled to other sites like Kahe Point and Waikiki to take some sampling. So it was a very time-intensive process, and we tried to facilitate exactly what the students wanted to do with their projects. We then spent a week doing data analysis, running through some statistics, and doing what we could in that short amount of time to convey the importance of proper data analysis in the scientific process. So at the end of that section, they developed a formal written report that had the main sections of the scientific paper, and they developed a PowerPoint presentation that they then gave at a public symposium on moku'aloe. And we had 5 different research projects that turned out really well. One of the territory structure of the domino damselfish. The students laid transects around the island, finding different territories and watching fish behavior. My group studied the effects of human impact on the biodiversity of sea urchins. So we sampled from 3 sites around the island that had different levels of human impact that the students defined, and then looked at the biodiversity of those urchins. We also had a group that looked at the effects of acidification on brittle star arm regeneration. That was a lab experiment. They actually removed arms from little Ophiactis brittle stars and then had different levels of CO2 introduced into tanks, and they calculated the regeneration of those brittle star arms and found some really interesting results. And another group looked at the distribution of feather duster worms, and others looked at assessing reef fish communities with monitoring efforts, kind of like we've heard about with other presentations today, around moku'aloe. At the end of every section, we of course had them do the pre and post tests, and these are the results from each of the subjects. As you can see, the improvement from pre-test to post-test was extremely significant with a p-value of less than 0.01. And all of the students then reported self-improvement after the program. So we had them complete student assessment of learning gains, or SALGs. And those SALGs were basically an opportunity for the students to tell us how they felt about their interests in marine biology before the program, what their interests were in higher education, and then we asked those same questions at the end. And all the students reported improvement in their science literacy skills and also an increase in their interest for higher education, especially marine science. So to follow up with the students, we have some social media efforts through Facebook and email that we're trying to keep in touch with the students and serve as a reference or a source for them for future endeavors, hopefully helping them sort out all the pathways that they have open to them. And the program will continue in future years, hopefully asking some of the students from this year to come back next year and be mentors, just like the rest of us were for the students this year. So my next steps, it's kind of all up in the air still. I'm still figuring out exactly what I want to do. But I'm going to be finishing my honors biology degree at Oregon State this year with the marine biology option and chemistry minor. I'll be working in a coral genetics laboratory during that time and writing an undergraduate thesis. For my graduate education, I plan on starting a PhD program in the fall of 2014. I'd really like to study coral recruitment and larval success, maybe here at UH, possibly in other areas of the world, eventually leading to a career in coral reef conservation and biology with an emphasis in public education and outreach, as I feel that that's one of the most important parts of successful management of these ecosystems. Overall, this experience was one that I will never forget, and it has been extremely helpful, not just to make connections in the scientific community, but to kind of expand my horizons for what I might want to do in the future. And this program is extremely important for increasing science literacy in the local youth, who are now that upcoming generation of stewards and scientists in our society, eventually leading to increased coastal society resilience and hopefully protection of these marine environments. I have a lot of people to thank for this program, especially all the staff and the fellow instructors at HIMB, all of the students from this year, my support system back at Oregon State, and my advisor, Dr. Malia Rivera. Are there any questions?
Thanks for the wonderful presentation. You know, I used to be the director of the marine science program at the Newfoundland Harbor Marine Institute in Florida Keys. Very similar to this in terms of the education, bringing youth in for hands-on. A lot of middle school and high school students come down for a 2 to 3 to 4 day program. And I've always thought Hawaii could use something like this, and I don't know the mechanics and the financial aspect of how it might work in Hawaii compared to how it worked in the Florida Keys. But I was wondering, in terms of some of the perils of bringing students out to the reef, insurance was always a big issue with our facility, and getting more costly every year. A lot of places couldn't start, one of these programs. Having lifeguards on hand and that sort of thing. I was just wondering if you could talk about any of those hurdles and challenges you had in implementing this program.
Right. The logistics was one of the most challenging parts of this project, and we were planning this last fall, last winter. When I first started getting introduced to Dr. Rivera and all the staff, that was one of the first things that we were working on. So all the staff were required to, because we were all scuba divers, have rescue diver certification minimum, so that we had that source of, I guess, kind of like we could be lifeguards while we were out there. We also hired lifeguards for any time that we had groups out in the water. And then transportation was a huge issue. These students, we had 9 from Waianae, we had a few from Castle, we had a few from North Shore. So what we had to do was coordinate transportation. We had one van that would do a shuttle around the island every morning. And then we had some students that needed to ride in with instructors. We had to carpool. We were done on the island every day about 2. We'd have the students go home. So we had to then coordinate transportation for them to get home and to do all of our field studies. So that alone was extremely, extremely difficult to coordinate. Eventually it did all work. But like I said, it was extremely difficult. So we also had liability waivers and lots of paperwork, media releases, everything like that we had the students sign, had the parents or the guardians work to sign. And that's one of the other difficult parts of this project is all of these students were chosen based on the fact that we wanted to help them pursue higher education. They were basically underrepresented in the marine sciences, but they also were having trouble in school. A lot of these kids maybe were underprivileged or from poorer families, so it was almost difficult to get in contact with parents and guardians at some points. So each student was a special circumstance, and we had to work individually with each one. And of course, all the logistics took quite a bit of planning too. So there was a lot that went into it, but we were very happy it worked out. Yes?
Kind of on the student level, how do you guys work with getting the recruits in? How did you get students?
It was an application process. Initially, we had notices go out to the schools, and a lot of the teachers would then suggest that might be good for that. And then Dr. Rivera interviewed every application. And she had the students come to Moku'olo'e, see the island, talk to her, and then she chose the students that she felt would benefit most from the program, not necessarily the ones that were the 4.0 students or the ones that would succeed just because they had their own drive. But she wanted to target the students that really needed the program the most. So it was an intensive interview process for that, but they were each hand-selected essentially.
Thanks. I think we'll have to hold the questions. If there's more, we can do it during lunch. But I do have a statement from Dr. Malia Rivera that I want to read. She emailed me some words since she could not be here. And apologies, I didn't memorize it, so I have to read it. Ariana came from Oregon State, where as an undergraduate she worked in 2 different genetics labs, including work on coral damophylagial symbiosis research. During her internship with Ellen and I, she worked alongside master's and PhD students, postdocs, and UH faculty, and held her own as a full instructor for an undergraduate level course offered to Hawaii high school students. She has a robust background in reef ecology stemming from her experience at the CIEE research station in Bonaire, where she studied progression of coral and algal phase shifts at Yellow Sub Reef. Combining her experience in coral ecology and her passion for outreach and education, she successfully took a major role in mentoring a group of young scientists in training in HIV during her Hollins internship. She's an exceptional undergraduate and was an absolute asset to our program this summer.
Thank you.
Thanks, Ariana. And now for something slightly, we go to aviation, and we'll be hearing from Ms. Dana Mueller talking about improving aviation weather services.
Hi, my name's Dana. I'm a meteorology major at the University of Oklahoma, also studying mathematics and business. And this summer I was at the National Weather Service forecast office here on the campus. And the project was looking at aviation weather around the island, specifically turbulence. So I was really interested in this project because of my interest in the applications of meteorology and atmospheric sciences to other industries, whether it be aviation, renewable energy, other sectors like that. So I contacted my mentor, John Bravender, and discussed kind of the purpose of the study, which was to look at turbulence around the islands for general and commercial aviation community, and looking at how different stability parameters, specifically inversion height, wind direction, and wind speed, played a factor in how turbulent regions shifted around the islands during different meteorological scenarios. A little bit of background. The data I primarily worked with were pilot reports called PIREPs, and they're sent to the National Weather Service office, and they contain information about aircraft type, geographic location of the report, flight level, the severity of the turbulence, and then the time and day. And of critical importance to this study was looking at how the terrain in Hawaii affects atmospheric flows, so looking at mountain lee wave-induced turbulence. So, as you all know, the cold mountains over to the east can play a huge part in creating turbulence in the Honolulu area. So I started out with data collection, and once I received a database of the pilot reports from my mentor, I went to a sounding archive, specifically University of Wyoming's sounding archive, and looked at data from 2002 to about June of this year. And I used atmospheric soundings, which are basically balloons attached with radio sound instruments that can measure temperature, GPS-derived winds, other data. And they're launched only at 2 locations in Hawaii, one on the Big Island and one on Kauai. And I chose the Kauai sounding location, just closer distance, and the terrain kind of mimics what we see here. So I chose the 0Z time sounding, daytime sounding to use for the pilot reports. So going through over 13,000 reports from 2002, went through the University of Wyoming database to gather inversion height, wind speed, and wind direction. And I narrowed that 13,000 down to 1,800. Only wanted to look at reports that were reported under 10,000 feet, considering this was only a low-level turbulence climatology. And specifically only looked at reports that were reported under the inversion height. So below the layer where temperature increases with height and you have a stable layer. Only wanted to focus on reports in the unstable layer where mountain waves can be found, seeing as they can't penetrate the stable layer. Also, I disregarded any reports of smooth or negative, as that would be a later focus, and right now I was only concerned with turbulence. So I started my analysis and decided to go with ArcGIS ArcGlobe program. So after I populated a database with the pilot reports and the information from the soundings, I uploaded it all to ArcGlobe and queried the information within that program. So I used 500 feet increments for the inversion height, wind speed every 5 knots, and wind direction every 10 degrees. Within those bins, I color-coded the reports by turbulence intensity. The reports come in and there's not like a single identifier for intensity of turbulence, so I just kind of grouped them all into the categories you see on the screen. And the colors correspond to the reports you'll see in the upcoming images on the next slides. But anywhere from light to severe, and then I think there were only 2 or 3 extreme turbulence cases. And important to consider with looking at turbulence intensity is that it's very subjective. When the pilots send it in, they could be flying anything from helicopters to small Cessnas all the way up to Airbuses and everything in between. So obviously the different aircraft are going to react differently to atmospheric flows. This image shows all of the reports, all 1,800 reports throughout the islands. And the image zoomed in on Oahu shows almost like a star-type pattern of the reports, and learned that this was due to the reports coming in based on an 8-point compass. So, 45 degrees, 10 miles from Honolulu International Airport. But then when they come to the National Weather Service, they can be decoded and switched to latitude and longitude. So that's why it might not look like there are 1,800 reports on the screen, because sometimes they got kind of simplified into a certain geographic location, and then when you're looking at it in the 3D mode, you can see that there are points at different flight levels but at the same location. So looking at first parameter, the wind direction, a lot of the reports came in from a northeasterly to easterly wind, the trade wind pattern, and the image on the top is the 70 to 80 degree wind range, and shows that the reports are scattered out in all directions basically from the airport. Whereas if you move to a more westerly wind, 260 to 270 degrees, The reports, while they're obviously less, are shifted more to the southeast, definitely east of Pearl Harbor. And the orange reports, which are moderate, are closer inland on the lee side of the Colaus, and the green reports, which are light, are focused more in the water and in the channel between Oahu and Molokai. Looking at inversion, similar pattern. You have 4,000 to 4,500 foot inversion height, which, considering the Colaus is about 3,100 feet in inversion height, 4,000 is very conducive for mountain wave turbulence. So you can see the reports are clustered on the lee side of the Colaus in the southeast. Again, orange reports, red, even more severe turbulence focused on land. Once you get up to about 6,000, 6,500 feet, you start to lose the effect of the mountain waves because you have your inversion way too high above the ridge to really create the trapped waves. So the reports are scattered more in all directions, and you have more light reports going farther out into the ocean. Looking at wind speed, I was told that the National Weather Service kind of uses 25 knots as the threshold to forecast moderate turbulence. So you can see in the top screen you have 30 to 35 knots, definitely more moderate to severe turbulence reported around the Honolulu area, whereas 20 to 25 knots in the bottom image, definitely see more light green reports, and it's scattered on all parts of the island and coastal waters. So looking at the prime conditions for mountain wave turbulence, you do need substantial wind speed. So in this case, I queried it with only 25 knots and above, and took inversions between 2,500 and 5,000 feet, as the Colaus range from about 2,500 feet to 3,100 feet. And I only took wind directions between 40 and 80 degrees. As for mountain wave induced turbulence, I want the wind to be approximately perpendicular to the ridge. And in this case, the red line kind of represents the ridge, and a 56-degree wind would be perfectly perpendicular. And the polygon indicates that the reports are summarized in a basically parallel nature to the ridge, and you do have a few of the orange reports, red being moderate to severe on the lee side of the mountains. And then I also created a few animations in ArcGlobe using a 3D analyst, and this is kind of a screenshot, but I went through and did flight routes from Honolulu to some of the other islands and typical routes so that maybe the forecasters or pilots themselves could see in a 3D representation of where the turbulence was reported, the severity of the turbulence at different locations and flight levels. I came late from my project, or from Australia, to start my project because I was on a different school schedule in Australia. So I didn't begin until June 17, and I have a few other things I would like to consider and investigate, specifically looking at the smooth and negative reports, just as important as knowing where the turbulence is, also looking at where you will not expect turbulence under certain conditions. And then for the reports that came in under conditions where there was no inversion, maybe looking at the influence of directional wind shear, possibly kind of replacing the inversion to create a stabilizer or like a stagnation point for the trapped lee waves. And finally, looking at visible satellite imagery to see if there's any evidence of the waves themselves in certain days where there were more severe reports. In summary, I took feedback from the community, aviation community, created a database and queried that data along with atmospheric sounding data to create graphics that can hopefully help forecasters better predict where turbulent regions are under certain meteorological scenarios so that they can better inform the aviation community of hazards due to turbulence. And I would like to thank John for all of his guidance and assistance, and the rest of the Weather Service Honolulu Forecast Office for their warm welcome this summer, and especially to the NOAA Hollings program for this great opportunity and all of their help throughout the past year.
Okay, we have time for a few questions.
Did you standardize the reports so that you had a baseline
severe to take into account the different types of aircraft that the reports came from?
There really, with the amount of data, there was no like feasible way to. It's talking about how like the different aircraft would react to turbulence, so that the pilot would categorize it as more extreme or light. Yeah, was actually probably the biggest issue I ran into with this project. There's studies I know going on in the meteorological looking about maybe quantifying that as an eddy dissipation rate and stuff like that, but that was definitely beyond the scope of this project. So.
Do you know if the local office has any predictive capability to model that they run tries to predict where turbulence may occur?
In terms of the model, I don't believe so. I think it's kind of rule of thumb of past experiences and reports coming in and stuff like that.
So that's where this is. So there's nothing validated against this kind of critical information.
Is John Robin here?
Yep.
Okay, cool. Can you say a few words?
Sure. It's John Brown, I'm a forecaster of the Weather Service, and this is my first time ever working with the Hollins program. And I must say, Dana's been a wonderful student to work with. I imagine going into this, I might have needed to provide more feedback to different students, but luckily she was able to take this program and run with it. And like she mentioned, she spent last semester in Australia on a different time frame. So she managed to get all of her finals done early, got here, and literally came to the office from the airport. So she really jumped in running, and to get all this data analyzed was a great thing to get done in such time, and I really appreciate having her work with us.
Thanks, John. Okay, up next we have Mr. Graham Sully. All yours.
Hi everybody, I'm Graham Soley. This past summer I worked as an economic research assistant under JIMAR in the socioeconomic division. The first of 3 projects I worked with Coulter. We worked on Hawaii Longline trip expenditures, and my main job was to work with the Access database. And Access, not as many people have heard about. Probably heard of Excel and Word and a lot of other programs, but this has more of a learning curve. And so a lot of the trip expenditures were based on these 2 types of fish. The first kind of figure and report that I designed, because that was my main job, was to design reports for Coulter to find specific things we wanted to know about the data, since there was so much. And the first thing we looked at was trip costs by year. So this included fuel costs and non-fuel costs, and you create it into a bar graph like this. And the way Access works is you put all your data in the table, and once you have a report designed that has, the figure that you want, 2013 will automatically appear up on the graph. So every time you're entering new data, these figures, you don't have to go in and plug data. They automatically create it for you. So that's what is really nice about Access. And this is a particular graph of swordfish, and I found through creating all these figures that swordfish, the trip costs were a lot more expensive than the tuna. The second type of report was average trip costs. So we wanted to see, during their trips, the fuel percentage, the non-fuel percentage. As you can see, fuel was a really important part of it, transportation, and so is bait and others. And the third type of report was the monthly fuel price. You can see the AAA fuel price, so the Honolulu AAA, they report fuel prices, and that was actually higher than what the fishermen reported as their fuel price. But as you can see, fuel is very important, so it's a good thing to keep an eye on for the fishermen. The second project was cost earnings benefits questionnaire. So it had five sections, and there was a lot of questions within each section, and it actually at one point overloaded the Access database, so we had to break it down and into different tables. So a lot of good and detailed information about the fishermen. We actually got to take a field trip to the fish auction on Pier 38, and this is where the fishermen, get their permits and submit information, and we got to see the various buyers, buying all the fish. It was pretty cool to see really just how big these fish really are, because I've never seen anything like it, and how they grade the fish too. So sushi grade, of course, goes for a lot higher, and the meat tends to have a lot more oil in it, so it has a lot more color, which is really cool. And the canned, they don't want all that oil within what they make, so they look for more cheaper, not as oily type of meat. And then I actually had an opportunity to, start a database from scratch, and this was about import-export data for the Honolulu district, and I got all this is public information. It's on the Economic Research Service website, and basically what I did was copy and pasted it, kind of leaned it up in Excel, and then you can actually take a lot of data that you have on, take it over into Access and really manipulate it and see what it can do. So there was four main, parts of the data. There was a product, so it would say the product name. It wasn't always that specific. There would be the revenue that included, and the kilograms. And then I made a pounds as well, because that's always good to look at. And then transshipment, there's, the number that it always shows for these is not really, the full number because of transshipment. So that is important to keep in mind. So I just wanted to show you two graphs that I was able to make, imports versus exports, and this is for the Honolulu district starting from 1997. And it's important to note the different y-axis bars as well. So the Honolulu does import a lot more products, but it's on a pretty, steady trend. It's not too dramatic in increasing or decreasing, but you can see that exports, especially since 2008, have been increasing pretty rapidly. And I was able to create a graph and like a little table underneath that in Access that showed the top 10 products and showed, the various, how they're trending for exports. And the important one to keep an eye on is the shrimp, fresh, dried, salted, and brine, because as you can see with the rest of the exports, they don't really seem to be dramatically increasing. So the shrimp is an important product to keep an eye on in the future. And this is also the top 10 import products. And the one I highlighted was the marine fish NSPF fillet. And there's also a frozen one in here, which is the darker blue one, if you can see. So those are two pretty important products, and they come in and they're not identifiable, so they can't say identify the tuna, so it's just listed under NSPF. And so it's had some pretty dramatic increases and decreases in recent years. And for the last thing I wanted to show was, since exports are becoming so important, to look at the countries with the max revenue products. So basically what this is showing is some of the most important products that we're exporting in recent years due to the dramatic increase in the important countries that this deals with as well, Japan abalone prepared, and just it's good to keep an eye on these different products and what their the amount of dollars that they're bringing in. And that's it.
If you go back to the imports and exports graph, there was a huge decrease. Yeah, I think it goes. Do you know what costs are?
Oh, this one? Yeah. Oh, yes. Thanks for reminding me. Sorry about that. So this is what's really good about Access is you can go ahead and start your graph, and we put in information for about what we have through April. And as we go along and put more and more information, we don't have to affect it. It'll automatically increase to the level where it'll meet probably close to the other points. So it looks like dramatically decreased at first. But yeah, as we put more and more information throughout the year, it'll either, rapidly increase or decrease. So that's what's nice about this database.
Did you happen to break it up into like monthly or quarterly sections? We looked at like every yearly, like, or imports and exports. Do you happen to look at any variations within the year? It's kind of interesting to know if they do export more in the wintertime versus.
Oh yeah, that would be interesting to look at. It's just like the way that they had it on the site. They have like the year and then the product because, and they don't include the monthly information because it really is so many different kinds of products and just so much data that would be probably pretty difficult to input that data.
Any more questions? Seeing none, I think Coulter Holberg is going to say a few words.
Hello, I'm Coulter Holberg. I'm with the Economics program at the Science Center. It's my pleasure to be part of Graham's internship. He's been very impressive with his work that he's done with us. He's created many different applications that can be used for users on down the road. He's streamlined many things. He's from the city of Louisville, Kentucky, and is a undergrad in the Department of Agriculture Economics at the University of Kentucky. And he's finishing up his last year there, and he's taking many graduate level courses, and that really reflects well on his character and attitude. He's a go-getter, he's a yes guy. Anything I've ever asked of him, he's produced, and he's produced more than what I could imagine. The applications, the reports that I asked him to do, he's went above and beyond. He's created things that I didn't think were feasible in the program. So it's really a pleasure to have him on board. And we thank you for your work.
Thank you.
Thanks. Okay, up next we have Taylor Whitkin. He'll be talking about socioeconomics.
All right, I'm Taylor. I'll be a senior at Colby College, majoring in environmental science with a concentration in marine ecology and policy. Right now I'm working with the Human Dimensions Research Program, and we're focusing on the socioeconomics of non-commercial fishing, mostly focusing on the small boat fishing in Hawaii and the Mariana Islands. So I've been working on a couple different projects, all that relate to the social aspects of fishing in the Hawaiian Islands, and also related to a couple different research questions that I've developed in doing a meta-analysis. This analysis is based off of a couple different surveys that researchers have done with fishermen over the past few years in Hawaii, Guam, and CNMI. to get a better picture of the social and economic characteristics of fishermen in each of these regions, and a couple different fisheries, both the pelagic and bottom fish fisheries. So in Hawaii, fishermen are defined less by static labels that we put on them, like commercial fishers or recreational or subsistence fishermen. They're more defined by what they do with their catch after the trip is over. So my research is looking at these post-catch actions, what fishermen do with their catch, whether they sell it, keep it for their families, or give it to friends, and how those actions correspond with how they define themselves as fishermen and how they define the different categories of fishing, like commercial, subsistence, recreational, cultural. There are a lot of different labels that we throw around. So the first project that I've been working on is looking to improve catch and effort data to aid in stock assessments in the Hawaiian fisheries. Right now, the Magnuson-Stevens Act does not require non-commercial fishermen to have licenses or report their catch. So there's a huge gap in fisheries data because non-commercial fishermen make up a large percentage of Hawaiian fishermen, and they're not reporting their data. We don't know how much fish is actually being removed from the ocean. We've been working with the Wailua Boat Club up on the North Shore, and we're getting both commercial and non-commercial fishermen to give us their catch reports so that we can better understand their fishing practices, how much they're catching, what they're catching, where they're going, and how much they're fishing. Because this project is so small, we really only have 19 fishermen involved. It's not actually going to help in bettering Hawaii's stock assessments, but it does give us a better picture of who these fishermen are, what their economic and social backgrounds are. And it lets the fishermen, once we give them our data and our analysis, it lets them better understand their practices, the practices of their peers, and potential effects that they have on the ocean. On July 4th, we got to go up to their annual Independence Day picnic, where we ate with them, talked story, and sort of just heard about fishing. And we also distributed the demographic surveys that are going to tell us about them, as well as explained how to fill out the catch reports that they're going to be giving us every month after they go fishing. And they fill out the catch reports after every fishing trip. They tells us what they're catching. There's a map with different regions in the Hawaiian Islands where they're fishing. So the second project is looking at the resilience of fishing communities in Hawaii, their resilience to change, as well as reliance of different communities on fishing. My role in this has been listening to and analyzing interviews that Don Kodowitz and Courtney Beavers did in Kona with fishermen, both commercial and non-commercial, fish distributors and buyers, as well as a couple officials from DAR. And it's been really interesting hearing the different perspectives of people with different backgrounds. Not everybody has the same opinions about how Kona has changed as a fishing community, whether it's actually a fishing community because of the impact that tourism has today, and also just challenges that the fisheries faces. Related to my meta-analysis, it was also interesting hearing the perspectives on how fishermen define different categories of fishing and how they define themselves. So this quote, 90% of boats out there have commercial licenses, but none of them are commercial fishermen. That sort of sums up one of the problems of the small boat fishery in Hawaii. Unlike a fishery like the Northeast, where you have full-time commercial fishermen that make a living off the ocean, and you have recreational fishermen that just go out a couple times and fishing for fun and just to get away. The lines between the different categories of fishing here are pretty undefined. You might have a fisherman go out holo-holo or just fishing for fun, and he could come back with cow fish, fish to feed his family. He might be able to give some of his fish to friends. He might be able to sell some of his fish to cover expenses like fuel, ice, and bait. And if he has a really good day, if he catches a nice big ahi, he might be able to make a profit. So the question is, which of these actions makes commercial fishermen? And how often do they have to perform these actions to be considered a commercial fisherman? So this graph is taken from a survey of Hawaiian smallboat fishermen. And it just shows that of the fishermen that that hold commercial marine licenses, which are necessary to sell even one fish, most of them don't do it so that they can make a living off it. They do it so that they can go out and have fun and also pay for the expenses of the trip, and they do it also to supplement their income. On Kona, a lot of the fishermen, the fishing is strongly tied to the construction industry, so when construction jobs go down, fishing goes up. This is taken from the same survey, and it just shows that the perceptions of fishermen on what defines commercial fishing is pretty varied. You have some people that agree with the Magnuson-Stevens Act that if you sell any catch, then you're a commercial fisherman, but others think that you have to sell all your catch to be considered a commercial fisherman. But this gets back to the question of, do you have to sell all your catch on every trip to be considered commercial, or do you have to sell all your catch on only a few trips? So in my meta-analysis, I'm looking at a bunch of different surveys. From the top two are from Hawaii, the smallboat fishery, smallboat pelagic fishery, and the bottom fish fishery. And the bottom graph is from Guam and CNMI. And it's just showing the breakdown of how fishermen define themselves and what percentage of catch different types of fishermen sell. So as you can see, there are differences between the fishery. Fishermen in Hawaii tend to sell more fish than fish in Guam. Sorry, that's commercial fishermen in Hawaii tend to sell more fish than in Guam, which might make sense because Hawaii is more commercialized. And so I'm looking at other fish usages such as home consumption, trade, and sharing with friends. So defining fisheries is important when it comes to protecting the rights of fishermen and also lifestyles of the different types of fishermen. The question in management is often who deserves access to certain resources and how much access. So with a project like this, defining the different types of fishing and looking at fishing patterns among the different types of fishermen could potentially give the most deserving fishermen, like the ones that are subsistence and use the ocean to feed their families, or the ones with the strongest cultural ties to Hawaiian fishing, the most access to fishery. And I'd like to thank my mentor, Don Kodowitz, who is not here right now, along with Courtney Beavers, Cindy Grace McCaskey, and Layla Siavanen, who I've been working with. That's it. Any questions?
Okay, we have time for questions.
Yeah, I noticed on your the first pie graph you showed,
Mm-hmm.
it said it doesn't add up to 100% because the survey participants,
Yeah.
did not apply.
Mm-hmm.
What exactly do you mean by that?
So this was the fishermen interviewed were both commercial and non-commercial fishermen. Some of them, the ones in this graph held commercial marine licenses. So a significant portion of the population, the question didn't apply.
Okay, so that's pretty simple.
Yeah.
We have lots of time, so that's great. You have quite a few. Oh, there's a question.
I know you got a lot of advice from all of us
Yeah.
in your recent email about moving forward and trying to better define with more nuance these non-commercial fishermen.
Mm-hmm.
I know there's significant issues with how some of the ways that we've tried to define them here. So could you talk a little bit about going forward and how you've been sussing out that advice? I know you got a lot from Justin, you got a lot from me, you got a lot. We've all got similar takes and then some departures from each other. What are you going to do here in the future with this? And I think it's an important topic.
Yeah, so Mostly the easiest thing that I've been looking at is the different usages of catch. One of the problems with doing a meta-analysis and using several different surveys is that the surveys, they ask similar questions but ask them in different ways. So like you can see in this graph, the categories are all different. People answered questions in different ways. And they also can identify with several different categories. So I also got a survey from Chris where fishermen were only able to choose one of the categories. So the data looks a lot different. So I'm just sort of trying to compare the different usages across different demographics, so the different fisheries, income levels, and also looking at the perceptions of the different fishermen, trying to compare how they use the fish to how they think commercial fishing should be defined.
I was wondering if there are any plans to expand and survey more people besides that one community, I think you said in Waimea?
Oh, not right now. I think on a larger scale, it could be used as a model. We could get more people involved. But this is sort of just we're just starting this up, and it's interesting just following this small group of fishermen, and we'll be able to get a really good picture for the entire year of their fishing practices. But I think a project like that would be really good, and actually, because it would be great to get an accurate assessment of how much non-commercial fishermen are removing from the ocean.
Yep. The differences in the commercial fishery licenses and what the fishermen hold, is there room here to implement something like what they do in Maine, where there's recreational licenses that's only for the family, or if there's going to be a move to just have the commercial license, and those who have the commercial license can or cannot sell?
I'm not really sure. All I know is that you need a commercial license just to sell one fish. I think it's interesting if you were to better define the different types of fishing if there were different licenses. And I think, a license, I think the commercial marine license is $50 a year, which isn't too bad, but I think there should be some sort of licensing system for all different types of fishermen, and that doesn't necessarily have to cost them anything.
Any more questions? I know you have a lot of mentors. Are any of them here?
Courtney's over there.
Do you want to say a few words? Or?
It's been really awesome having Taylor here. He kind of just stepped right in, and he's been incredibly perceptive about a fishery that's very complicated. It takes a lot of people years to kind of understand all the nuances between all the different types of fishermen here. And he kind of jumped right in. He read all the literature. He started getting out into the field with our other researchers and meeting people, listening to interviews, and taking down notes. And just really, I was really impressed with this presentation because he really put it all together. So, thank you very much.
Thank you.
Thanks. And our next speaker, our last before our lunch break, is Theodore Volsky. The floor is yours.
All right, so now that I'm the last presenter before lunch, so I'll try and go quick because I'm hungry too. So, okay. So my name is Theo Kowalski. I'm with the Collins program, and this summer I spent my time working at the Pacific Islands Regional Office of the National Marine Fisheries Service, and I'm here to tell you about my project, which explored the sociocultural and economic barriers to small vessel and indigenous participation in the American Samoa longline fishery. So just a little bit about myself real quick. I study marine policy at the University of Maine in Orono, and most of the work that I do up there centralizes on social science. And so when I was looking for a Hollings project, I thought, now where is the best place that I could really apply my knowledge of cold water, subarctic fisheries? And I thought, all right, how about Hawaii? Or why not the Southern Pacific? So, but in all seriousness, this project really did grab my attention because it presented such a great opportunity to explore such a broad range of components to fisheries management, which is something that I'm really interested in. So I had a chance to look at economics and ecosystem biology, cultural anthropology, sociology, and the list just goes on and on. And so I thought that having that really broad range of components tied in really nicely with NOAA's long-term goal for resilient coastal communities and economies. So I was selected for this internship based on some previous experience that I had looking at social dynamics of fisheries in Maine. And I was selected by my mentor, Chris Hawkins, with the Sustainable Fisheries Division of the regional office. He really helped familiarize me with the project focus, which was the longline pelagic fishery in American Samoa. But more specifically, what I looked at was the decline of the small vessel fleets in American Samoa. And I'm going to talk a little bit more about the longline fishery out there and how that's structured, but just a quick overview. Vessels in the longline fishery in American Samoa are separated into 4 class sizes, and the class sizes are based on vessel length. So you start with the Class A vessels, which are smaller, less than 40 feet, and you go all the way down to Class D vessels, greater than 70 feet in length. And most of the indigenous fishermen in American Samoa fish from small vessels called alias, which would fit into that Class A category. And the thought process is that indigenous fishermen can enter the fishery using a Class A vessel and eventually work their way up to fishing from a larger Class D vessel. But the trend has been a little frightening, and Class A vessels have been in a steady decline to the point where now there's just one Class A vessel fishing in American Samoa. And this has been a cause for alarm for those that want to see indigenous fishermen taking part in what's a traditional fishery of theirs. And so my big research question throughout the summer was, what happened to those small boats and why did they happen? So just a little quick overview of where I was looking at. I was focused in on American Samoa, which is just one of several jurisdictions of the regional office, which also oversees the Hawaiian Islands, the Mariana Islands, including Guam, and also some of the Pacific remote areas, including Wake Island. Some of you might be familiar with the Battle of Wake Island from World War II. That's where it's situated. But American Samoa makes up about 115,000 square nautical miles of this Pacific Islands region. And it's been separated politically from independent Samoa to the west for just a little over a century. But the greater American culture actually dates back about 3,000 years. And the way of life in both independent Samoa and American Samoa is dictated by Pa'a Samoa, which translates to the Samoan way. And it's the cultural, traditional system of beliefs that really describes each person's relationship with each other and with the greater community. And there's a very strong focus on family. And much of the village structure is centered around extended family, and resources are shared throughout these communities. In American Samoa, there's not too much quality land for farming, and so fishing and resources from the sea have really provided sustenance for these people for thousands of years. And so fishing is very deeply ingrained in their culture. And today, the most common fishing practice is longlining. Longline fishermen use miles of line containing baited hooks. They're fishing primarily for pelagic species such as tuna. And the hooks are set and then reeled in after about 24 hours or so. And this figure here shows an example of a longline fisherman bringing in his line using a manual reel. And longlining is pretty new to the territory. It was introduced in 1995, but today it's a multi-million-dollar industry, and it accounts for nearly all of the pelagic landings in American Samoa. And the first longliners in the area fished from those small boats that I mentioned before, the Alia vessels, and this is an example of an Alia boat. They're small, usually about 24 to 38 feet in length, twin-hulled and aluminum. They're built by locals in the islands. They're powered by small gasoline outboard engines right here, usually about 40 horsepower. And then the hooks are set from that manual reel, and usually the Elias can set about 350 hooks per set. And there was a steady growth of these vessels entering the fishery until about 2001, when there was a huge increase in the number of much larger monohull vessels entering the fishery. And with those new vessels came a huge surge in fishing. Since these boats could travel much farther offshore, and they could set about 4,000 hooks per day, as opposed to the 350. And so there was a real cause for alarm that uncontrolled growth within the fishery would have some really damaging impacts on the local fish stocks and in turn the Alia fleet. And so the solution put forward by the Western Pacific Fishery Management Council was a limited entry program for the longline fishery. And so there were a limited number of permits given out to vessels looking to enter into the fishery, and the number of permits was decided by the vessel size, the class size. As you saw before, there were those 4 class sizes from A to D. And preference was given to the Class A vessels, which was made up of the Alia fleet. And the hope was that the Alia fleet would be provided with some security in the fishery, and the influx of larger vessels would also curb that influx of larger vessels so as to keep fishing effort down. But
it didn't quite go as planned, and the results, again, looked a little something like this. There's that decline in the number of Aaliyah vessels fishing, to the point where there's just one today. Whereas these larger vessels, these Class D vessels, after the major increase in 2001, large vessel participation has remained pretty stable to the point where today they make up the majority of the fishery. So what happened to those small boats, and what caused that major decline from over 30 boats fishing to just one within that Class A category? And council members are trying to find answers to these questions now. They're even looking to amend the limited entry program, but they don't quite have all the information that they need. So my job for the summer was really to help to find that information that helped provide fishery managers with information they need to make those informed decisions. And so to do this, I did a lot of reading. This project utilized desk-based research, and it looked to pool resources that were already available, but pretty scattered. And so I took information from a lot of different sources, from the Fisheries Council, from the regional office. I looked at reports, staff reports, got a chance to speak with some of the staff members who had some expertise in the area, and I put all this information together to try and find some trends that could hint at that decline in Aaliyah participation. And what I found was that there really wasn't just one answer. It was a mix of a few. Could have been a mix of a few different things. And those possible factors could really be split into two categories, one being economic and one being sociocultural, which dealt a little bit more with the fishermen themselves as well as the fishery managers. So to start, I'm going to look at some of those economic factors. And when I was looking for trends in the fishery, the first place that I looked was landings data. So how has the total catch for these fishermen changed over the course of the fishery? And it's changed quite a lot. So at the beginning, catch is relatively small. Once you see that major increase in those larger vessels, catch skyrockets. And it's been pretty unstable since then, to the point where today, fishermen are only landing about half as much fish as they used to. But the problem is that they're fishing just as much. So this figure here shows the number of hooks set annually within the longline fishery. And today, the number of hooks in the water is just about the same, if not maybe even a little more, than when those larger boats entered. And when you put the hooks data with the landings data, you end up with a trend that looks like this. So this figure shows catch per unit effort, or CPUE, which here is described as the number of fish caught for every 1,000 hooks. And CPUE is pretty high at the start of the fishery, when just the Aaliyahs were fishing, but again, with the entrance of those larger boats, CPUE has been in a decline to the point where now it's only about a third of what it used to be. So the thing to take away from this is that fishermen just aren't catching as much fish as they used to. But it's not just all about the fish. There are also some fishery-independent factors that cause some problems for fishermen, the most critical being the rise in gas prices. As I said before, these Aaliyah vessels, they use gasoline-powered engines, and when you're using a gas-powered engine, and the price of gasoline goes up by almost $3 a gallon in 10 years, you're not going to be able to travel as far. And so these fishermen they couldn't afford to travel very far offshore. And so with the inshore stocks being fairly depleted, they just weren't able to catch as much fish. And if you couple that with the fact that the price of tuna, the target species of these boats, didn't change at all in this entire period of time, there's nothing to balance out that increase in other prices. So as other prices are going up, there's nothing to balance out that cost to go fishing. And mooring charges also were an issue. In fact, just this year, fishermen in American Samoa longliners, they wrote a letter to the government looking to negotiate port charges because they couldn't afford to keep their boats tied up anymore. Now, apart from these economic factors, there's also some issues that stem from the limited entry program itself. For example, a requirement to have a permit within the program, you need to provide some sort of evidence that you had fished for pelagic species, you had longline for pelagic species in the past. But for some of these American Samoan fishermen, that idea of keeping records and having documentation like that is relatively new. And in fact, a logbook system wasn't even implemented in the territory until the late 90s, so after the fishery had already formed. And so these fishermen didn't have the documentation that they needed to receive a permit. And another component of that documentation was vessel ownership. They had to prove that they owned the vessel they planned on using to fish. But in American Samoa, where the resources are more communal versus personal, you run into some issues there. And in one instance, a daughter who was applying for a Class A permit vessel tried setting her father's Aaliyah vessel as her own, but since she didn't own that vessel, she was denied her permit. But maybe the issue goes a little farther beyond the management measures, and instead extends into the greater community. American Samoa is an area that's very steeped in tradition, but over the last few decades, there's been a lot of changes. It's become much more westernized, much more commercial, and so fishing just might not be as important anymore. And especially with a lot of really good jobs opening up within the government sector, fishing just might not be a lucrative occupation for these fishermen anymore. But this we don't know for sure, and I wasn't able to cover this in too much detail, at my time here in Honolulu. So this would be something that would need to be explored further in order to more fully understand. So that is why I plan on turning my senior thesis project this year and using that to expand upon those sociocultural factors and see if I can look a little further into what is the situation over there in American Samoa. So I would love to have the chance to actually travel out to American Samoa this year, talk to stakeholders, talk to fishermen who had a part of the history, and hear what they have to say on these issues. Because there really are more questions to ask. And we won't fully understand the situation until we get a chance to talk to the people that were involved. So to summarize, economic factors most likely contributed the most to the decline in Aaliyah vessel participation. There was an increase in the cost to go fishing mixed with a major decrease in catch per unit effort that meant that fishermen just couldn't break even. They couldn't make a proper living with the conditions that they were faced with. And to make matters, management measures that had been put in place to try and help them could have actually made the process more difficult. But there's still more to explore on the subject, and we need to talk with stakeholders out in American Samoa, the fishermen and the community members, and gain their perspective, because having that fisherman and community perspective is really important in providing a much more comprehensive understanding of the status of the fishery. And with having that stronger understanding, fisheries managers such as those with the Management Council would have the information that they need to make those informed decisions about what steps they need to take to better promote sustainability and stewardship within the American Samoan fishing community. And so with that, I would like to say, as I say in American Samoa, Pa'apate, which thank you. Thank you to a lot of people out here, especially my mentor, Chris Hawkins, the entire staff at the regional office, the entire council staff, and especially thank you to NOAA, the Office of Education, with the Hollins program for providing this awesome, awesome opportunity. And I would be happy to entertain any questions.
Okay, we have time for a couple of questions.
Do you know what percentage of the fleet is American Samoan versus outside countries? Because it seemed like when we were down there, that was a huge influx of outside.
Yeah, and in fact, most of the owners of those larger vessels, those Class D vessels, they're not from American Samoa, and that's really been part of that cause for alarm, is that these fishermen, these native fishermen, are being edged out by these foreigners coming in fishing in their water. So yeah, there's a really very big difference there in the fact that these larger vessels that have now more or less taken over the fishery are from these outside vessel owners versus the indigenous American Samoans, which would fish from these smaller vessels, have more or less ended. Like I said, there's just one more Aaliyah vessel that's still fishing in those waters. So there is that major difference there, and that's something that they're trying to look at.
It would also be interesting to know that, like, there was a really bad tsunami. I don't know what year it was.
It was 2009.
Oh, okay, so it's 2009.
Yeah, there was a 2009 tsunami in 2009, which did even more damage to the Aaliyah fleet because the few Aaliyah vessels that were left, that were tied up in the harbor, were more or less damaged beyond repair. So, yeah, that's also big. That's also a very good thing to note.
And it's also one other thing to know. I don't know if it might be of any interest to you, but we were down there. Most people in American Samoa can't swim very well, so that could be an influence in going out in a small boat. They might. I mean, it's something to consider as a social factor.
It could be. Yeah, exactly. There's yeah, there's a lot of other things that really do need to be explored a little further, and especially with the area and the people in the area. Yeah. So I mean, there's a lot. Yeah.
You might get a little more insight into like social factors like that.
For sure. Thank you. Any other questions?
If no more questions, maybe your mentor would like to say a few words, Chris?
Absolutely. He was my fourth hauling scholar, and I've got to say, I don't know about your other mentors, but they make me feel like I was playing with Play-Doh and Grant when I was an undergrad. They just blow me away, all these presentations, and all of the other ones as well. Theo probably doesn't realize it, but he almost wasn't selected for this project because when we were having our interview, being from New England, I found out that he's a Yankees fan. Standard interview question, if anybody needs to check out on the interview forms in the future, I'd be happy. In all seriousness, I don't know how that happened, but you Connecticut New Englanders are a little different.
We're a strange breed.
That's Massachusetts New England. In all seriousness, though, I think I'd like to echo what a lot of the mentors said was, I mean, Theo just jumped in from day one to understand a fishery
that he had no hope of seeing in person during the summer due to sequestration and other issues. He did a ton of reading. He was very intuitive, like Courtney mentioned with Taylor, in asking the questions. And more than all of that, I mean, his personality was just so well suited to this project. I've had really great Hauling Scholars over the last 3 years, the 4 Hauling Scholars. But I think Theo's, his work ethic and his personality were really well suited to this particular project. So I'm very pleased that Theo is thinking about and hopefully will translate this to this senior thesis project, and that I'll be able to help him get some funding together. I know you've applied for a grant from the university already, or you will be soon submitting that to get some travel funds to go to American Samoa next winter, next January for a couple of weeks. But I'm happy to help, as I've indicated, to get him down there. I think it's so important to really talk to the folks, especially who've been displaced. I mean, that's in social science, it's one of the biggest issues is the displacement effect, and trying to find the people that you're trying to talk to who are no longer in the fishery, and how do we talk to them. And so getting on the ground, getting your boots on the ground, and hunting those folks up. And lastly, I just say I gave Theo a detective story this summer, which and I said to him in the beginning, run with this. There are no right or wrong, answers and ways to do this. Figure this out. The information that we'll have at the end of your internship is more than we have now, and he has really taken that to heart and done a great job. So thanks very much, and we really appreciate your service this summer.
Well, that's it. We're free for lunch. That was a great set of presentations this morning. It's kind of frightening. I have to dial up my game to keep up with these interns once they enter the workforce. How about a round of applause for the first 2 sessions this morning? So, free for lunch until 1 o'clock. Okay, we're going to get started. Our moderator for the third and last session is Aaron Olson here. Before I turn it over to Aaron, I'd like to just say a couple of quick comments. We have been recording this on GoToMeeting, as well as Marty back there videotaping. So we have a couple of things that you could hopefully get a hold of later. And I'm glad to say the morning session did record successfully on GoToMeeting. I already checked it. So we have that for you to take with you at some point. And without further ado, I'll turn it over to Aaron Alston, who will be moderating this session.
Hi, good afternoon, welcome back. I have to say I missed the morning, so I hope I follow in step as I'm supposed to. But just to start out, so welcome back, and I'm going to introduce our next speaker, Sasha Giametti. Her mentor is Alan Tom, who's not here this afternoon, but she's going to speak with us. She's an NOS Haulings intern for the summer, been working on Maui, and from Eckerd College, and she's going to be talking about some fish pond projects.
Hi. Hi everyone, my name's Sasha. I've been working this summer as a Haulings intern at the Hawaiian Islands Humpback Whale National Marine Sanctuary, which is, I've been in Maui, in Kihei. And yeah, so I'll tell you a little bit about my project, which has been an exploratory study of the interior and exterior microhabitat of the Ko'i'e fish pond law. And I go to Eckerd College. I'll be a senior there this year studying marine science. Okay. So the Hawaiian Islands Humpback Whale National Marine Sanctuary, I know we've been hearing more about fisheries. So the National Marine Sanctuary, this program in Hawaii has been designated to protect the whale population that migrates during the winter and spring seasons. So it's under the National Ocean Service, and it encompasses the regions surrounding the main Hawaiian Islands. And in particular, the office that I've been in Kihei has a educational visitor center, which is dedicated to outreach and informing the public about whales and NOAA in general. So there I've been working with my mentors to develop this project. And in particular, I've been at the Ko'i'e fish pond, which is just adjacent inside of, on the shoreline surrounding the visitor center. And that is itself managed under, it's a cultural heritage site, so associated
with the National Marine Sanctuary, but it's also managed by the Maui Fish Pond Association. And the originally this pond, I don't know how much you guys know about Hawaiian fish ponds, but this pond was built about 500 years ago by ancient Hawaiians for Hawaiian chiefs. And it's a way of capturing fish and raising them for food. And so it's a rock wall that encloses the shoreline. And all of the rocks were brought down from the mountain to the shore. So it took a lot of effort to get these started. And since then, a lot of them have been declined because it takes a lot of upkeep to keep those. But what I was interested in is the ecological systems inside the pond and how that plays in the culture of Hawaii. So the pond itself is currently being restored by the Maui Fish Pond Association. That's a picture of it. It's about 3 acres in size, and it used to be a lot bigger, but since there's been a lot of erosion and sediment coming into the pond, and the shoreline has changed quite a bit. But currently it's being restored and isn't used for raising fish. But what I was kind of interested in, the bigger question was, what impact does this have on the ecosystem, and how does it facilitate creating little micro-ecosystems in the area? And so what I noticed was that the wall itself plays host to a lot of species of invertebrates and algae, and native and invasive plants. So more about the project itself. So what I set out to do was compare different sections of the walls. And so I wanted to compare the interior wall and the exterior wall in particular. And so the first thing that I set out doing, the wall's kind of broken up into 3 parts. And so I went out there with Erica, another intern that we'll be presenting later, and we went out to measure the wall. And so for sampling, the measurements would tell me where I would sample. So I would use a random number generator to calculate how many feet out I would go. So it was kind of an attempt to get as much of the wall as possible and in a random manner. And so I was using a quadrat, 2 foot by 2 foot quadrat, and sampling the intertidal zone. And over this course of about 6 weeks, I did 32 sites, and so there's 2. I did interior and exterior each one, so there's 64 total quadrats that I did. Oh yeah, and that's that just kind of marks the blue dots are where I did sample, and parts of the walls that I didn't sample, they are currently rebuilding or aren't exposed to the water in the same way that other parts were. So these are some of the species that I did find. There were about 22, and most of them I identified down to the species, and then I also show the Hawaiian name, which a lot of times the organisms have cultural relevance, so the ones that do have Hawaiian names. And interesting to look at if they're native or endemic. And with the algae, there were also a couple invasive species, particularly the hookweed, and there's also the lettuce algae, which is native but also considered invasive because it's green sea turtles, which eat this algae, have been declined, so now this species takes over. So now to get what I found. So I found an overall greater abundance of invertebrates on the exterior wall, than about 25% more than on the interior wall. And also I broke this down into what species I was finding. And so primarily I found the false upihi, which are limpets, and those were primarily abundant on the exterior wall, which kind of shows how the average kind of changed. So without the false upihi being present, the interior wall would actually have a higher abundance of organisms. And so I looked at kind of
trying to understand why this would be, and because the reason for studying the interior and exterior walls is that they're kind of completely different environments, with the exterior wall being exposed to a lot more wave action and the interior wall being a lot more stable. And so I also calculated the Shannon-Weiner diversity index, which increases, the index increases as evenness increases and as the number of species. So this just shows that the interior wall, which is more stable, has a more evenly distributed number of organisms. And then this is also, I did this with algae, or in Hawaiian limu, and shows that there was a lot more algae cover in the exterior wall. And my hypothesis is for this: the wave action on the exterior wall of the pond prevents a lot of predation from fish and causes higher algae on the exterior. And this kind of breaks down the different abundances of algae that I found. These are names that, some of the names I gave them just for when I was identifying them. And the hookweed and the lettuce algae are considered invasive. And finally, this is something I was playing around with, creating a visual representation of the organisms found along the fish pond wall. And it kind of is interesting to see what organisms are found together and how urchins maybe only have inhabited that exterior and interior wall of the western side, and how the OPE are found on the exterior and on more areas with higher wave action. So this is just kind of a graphic I've been experimenting with and trying to visually represent the data that I found. And this is another way that I was playing around with that. This is a graph showing the distribution and abundance of the falsa pihi, the most abundant species in the pond, and how on the exterior wall it shows that some of the areas that are high in abundance on the exterior aren't abundant on the interior, which maybe could tell us a little bit about the habitats that they like to colonize, perhaps more unstable wave impacted. So the findings, I didn't find anything groundbreaking, but I think it was a very interesting look at what lives where, and maybe a stepping stone to understanding how things colonize man-made structures, such as the fish pond. And so as an application, it could work to monitor, and it could be served as a baseline study and watch how the organisms change as the wall is continually rebuilt. And as a future study, I think it would be interesting in better understanding this colonization, about monitoring right after the rebuilding period what comes in first, and also for a future study, I would be interested to measure quantitatively more other factors that might influence the organisms that live there. So next steps for me, if I'm talking to advisors about turning this into a senior thesis, and with that I would do more statistical analysis and t-tests and things. And for my future, it's kind of open-ended for now, but some of the things I'm interested in are sustainability and humans, how they play a role in ecosystems, and even plankton and taxonomy interests me. So I'd like to thank my mentors, Alan Tom, Nancy Dashba, Ka'au Abraham, and Ed Lyman. They're all kind of helping me along, and also the Maui Fish Pond Association that let me use their pond for studying. So, and thank you so much for allowing us to come from Maui to be here. Thank you.
Any questions for Sasha? Not to totally put you on the spot, but can you pronounce the Maui?
I'm not sure. I've heard them say it a lot, but I don't know if I'll be able to repeat it. Okay. Okay, Sloan. Yeah.
Sam.
So you mentioned right at the end, looking at other factors that might affect the distribution of foods inside and out. Did you, or is anybody thinking about looking at seawater chemistry and temperature and so forth inside and out, and also see if
Yeah, that was part of my original plan, was to do some water quality monitoring, but in effort to keep it as simple as possible, because I was doing all the research by myself, and so I was trying to keep it as simple as possible. But I think that would be interesting, is looking at water quality, and they do have water quality volunteer groups that do monitor temperature and salinity and all of that. And I also think it would be interesting, I don't know if they have any plans to specifically tie that into my project, but also quantifying the amount of wave action that occurs around that area would be interesting.
Other questions for Sasha?
I have a question. For the false OP, it looked like there was alternating abundance between the outside and inside. Was that, did you notice that too? For a particular section of the wall, if it was high on one side, it was low on the other side, and vice versa?
Yeah, I'm not completely sure exactly why that would happen, but I think the presence of algae could have something to do with that, because that's what they feed on. But I think there's so many factors. That's a good point, though.
Okay, so I think when mentors have been here, we've asked them to say something about you, but since your mentors aren't here, I guess we'll just put you back on the spot, talking a little bit about what you hope to do next and your future and any other things you'd like to talk about.
Yeah, so I'm kind of keeping it open-ended once I graduate, hoping to eventually go to graduate school, but also getting some experience in the field and finding out what I really want to continue with. But I am really interested in plankton and doing plankton tows, and that's what my original project was going to be, focused on plankton, but I had to modify it a bit because of the resources that I had. So I think I just really enjoy being out in the field, and we'll see where that takes me.
Thank you. Up next, we have Chantel Chang, also a Hauling Scholar, working with Ocean Service here on Oahu. Her mentors are Randy Kosaki and Daniel Wagner, who I believe are also not here this afternoon. But thanks to them for hosting her this summer. And she's going to talk to us about macrobenthic organisms and mesophytic corals.
Hi everyone, I'm Chantel. I am a math major here at University of Hawaii at Manoa, and also pursuing my certificate in the Marine Option Program. This summer I interned at the Papahanaumokuakea Marine National Monument in Hawaii Kai, and that's with NOAA and its National Ocean Service. The title of my project is The Abundance and Distribution of macrobenthic organisms at mesophotic coral reef ecosystems in the northwestern Hawaiian Islands. So a little bit about the monument is that it was established in 2006, and it encompasses over 360,000 square kilometers surrounding the northwestern Hawaiian Islands. And the vision of this monument is to forever protect and perpetuate ecosystem health and diversity and Native Hawaiian cultural significance of Papahanaumokuakea. Now, some of the terminology that I'll be using include mesophotic zone, which is sometimes referred to as the twilight zone, and it's the zone with low light. It typically refers to depth ranges between 30 and 150 meters. That bottom depth sort of varies depending on your location and the conditions of the ocean. And within these mesophotic zones, I'll be talking about the coral reef ecosystems, which I'll be calling MCEs, just for some simplification. And these are defined as communities of reef-building, light-dependent corals and organisms in the mesophotic zone. And lastly, the macrobenthic organisms are the ones that we're looking at. So these are just things that are on the ocean surface, or ocean floor surface, and can be visible by with the naked eye. So some of the examples of things that I was looking at include corals, algae, sand, etc. So MCEs, as we heard earlier in the morning, are largely undersurveyed worldwide, and especially in places such as
the northwestern Hawaiian Islands. Therefore, the goal of this project was just to get a baseline of what's out there, what's on the benthos in the mesophotic zone of the coral, the northwestern Hawaiian Islands. So since there were no previous data that was available on this certain topic, I compared this data that we got from this past research cruise to the shallow water data from previous studies on the northwestern Hawaiian Islands. So I'm going to talk a little bit about coral morphology. I'm going to be using this color coding throughout this presentation. So the orange goldish color will represent shallow water and the blue will represent MCEs. So corals grow differently according to the environment that they live in. You can see at the top you have Parietes lobata in shallow versus MCEs, and directly below that is Mantipora capsata, also shallow versus MCE. And you can tell that the shallow water corals tend to grow upward and have branch-like formations, whereas in the MCEs you have flat plate-like formations. And this is an adaptation so that they are able to more efficiently absorb light since there is so little light in the zone. A previous study showed that Parietes lobata and Passiflora are the dominant corals in the northwestern Hawaiian Islands in shallow waters. And another study showed that Mantipora capitata was the dominant coral in the upper MCE of the main Hawaiian Islands. And Leptocerus was the dominant coral in the lower MCEs of the main Hawaiian Islands. So we actually started off this internship going on this awesome research cruise to the northwestern Hawaiian Islands this past May. And I was very, very lucky to be able to join them. I served as an algal specimens processing lab assistant, so I got to take pictures of the algae and freeze them, put them in formalin, ethanol, all kinds of stuff. It was a 26-day research cruise and aboard the NOAA ship Hi'ialakai. During the research cruise, we went to 3 different places. We went to Nihoa, French Frigate Shoals, and Laysan. And so what I want you to note is the difference in latitudes between these 3 different places. At Laysan, Laysan has the highest latitude and Nihoa the lowest. And this is going to be important later for our data interpretation. So the way that we were able to map out how much of the macrobenthic organisms that were there in the places that we went to, there were technical divers that dove down to depths of around 40 to 70 meters, and they took on a standard half-square-meter photo quadrant and took pictures along a 25-meter belt transect. And there were a total of 16 dives, and I processed 319 images using coral point count. For that processing, that took up the bulk of my time, the internship in the office after we returned from the research cruise, because I assigned 100 random data points to every single photo quadrant image, and then I had to identify what was under each one of those points. So I won't be able to go over all of the results that we had because due to just time constraints, I'm going to go over some of the coral findings. So this is a bar graph of the percent cover of coral and French frigate and Laysan. So if you look at French frigate shoals and Laysan, that was what I was expecting to see. I was expecting to see more coral cover in the shallow waters when compared to the deep waters, to the mesophotic zone. However, we got kind of a surprising result at Nihoa, where there didn't seem to be a significant difference between how much coral there was in the shallow water when compared to the mesophotic zone. So I thought maybe it has to do with, the latitude, that Nihoa is lowest in latitude. Since it's closest to the equator, then it'll have more sunlight and warmer temperatures of water. And I think that explains part of it, but what explained it even better was this previous study on temperature gradient across the Hawaiian archipelago. So if you take a look at the first graph here, you can see Nihoa, which is lowest in latitude, and you can also see Midway and Curie, which is the northernmost atolls of the chain. And so if you look at the red section, that's the warmest temperatures, you can see that that thick top layer of warm water at Nihoa eventually gets shallower and shallower as you go north and higher in latitude. So if you look at the typical mesophotic zone between 30 and 150 meters, you can see that the temperature profile is very different when comparing, the Nihoa to Midway. So this sort of explains why you would find more coral in the depth of the Nihoa dives, because we were basically diving at the same depths between 40 and 70 meters. And so at each dive, you're probably going to reach different sections of the MCEs according to where you are, which island or atoll you're on. So say you do a 50-meter dive, and you can see that there's a temperature difference between Laysan and French frigate shoals. So this idea of temperature gradient and the varying depths of the MCEs also help to explain the differences in coral dominance between the three different sites. So if we're at Nihoa and French frigate shoals, you can see that the mesophotic data, the blue bars, are pretty similar in distribution, and that Mantipora is the dominant coral, and that there are still some traces of Parietes and Passaliflora, which were the shallow water dominating corals. So I think that in Nihoa and French frigate shoals, we're probably just reaching, the top of the upper MCEs, but at Laysan, there's a huge difference where there's only Mantipora and Leptocerus, which are the deep MCEs dominant corals. So yeah, as you increase in latitude, you can see that Parietes and Passaliflora in the first two columns, the blue bars, they decrease. Leptocerus increases when you go from Nihoa to French frigate shoals to Laysan. So in summary, we're able to obtain a baseline in quantifying the abundance of macrobenthic organisms at MCEs in the northwestern Hawaiian Islands. And when comparing it to shallow water data, we're able to see trends that there is a lower abundance of coral in the MCEs when compared to the shallow water. There are less dominance by Parietes and Passaliflora and increased dominance by Mantipora and Leptocerus. Thank you everyone for coming, and Don for setting this up. I wanted to thank family and friends for the support, thank Noah for the Holling Scholarship, Dr. Randy Kosaki and Daniel Wagner for being my mentors, Hi'i Alakai, Papahana Mokokia, and Dr. Heather Spalding.
Questions for Chantal? John?
I'm just wondering how the dives, how the dive sites were selected and how much any change in, were they randomized around each island, and if that might affect the results?
Oh, they did benthic mapping with the Hi'i Alakai, I think, radar, and then they looked for slopes where they thought that the coral reef ecosystems might be. So I think the MCEs tend to occur like right at those slopes where there's a huge change in depth. Yeah. Yes?
So as far as the surveying goes, with these mesophotic reefs, the divers obviously have to go down deeper and therefore can't spend as much time that far deep. Was there a way to keep it consistent between the shallow water reefs and deep water reefs with regards to how much time they could spend surveying each?
No, I think they just went down as far, for as long as they could. They used mixed gas technologies and closed-circuit rebreathers. It was actually the first research cruise that they used closed-circuit rebreathers for NOAA research. Yeah, so it's pretty exciting.
Are the sites that they surveyed, have those been the same sites that have been surveyed since they started the research in 2009, or were they new sites this year?
You know, I actually didn't have a chance to look at the previous data, but I think that they did go to these places, and we were hoping to go to Mokumanamana also, but the conditions weren't right, so we just spent an extra day in Laysan.
Other questions for Chantal? Okay, since Randy and Daniel aren't here, if you could talk a little bit about your plans and what's next.
Sure. Yeah, so like the other Howling Scholars, I'll be flying up to DC soon to present this at NOAA headquarters, and I'm hoping to publish these results. I have to do more statistical analysis because the bulk of this internship was, you know, the research cruise and then looking at coral point count, looking at all these images. So I have to do more analysis on this. And I'm also working on graduate school applications, hopefully to get my master's in oceanography or fisheries management.
Thanks. She's also joining us from as a Howling Scholar from the National Ocean Service in Maui, having worked with the Humpback Whale Sanctuary for the summer. Erica.
Thank you for the introduction. Hi guys, my name is Erica and I'm from the College of William & Mary. It's a small school in Williamsburg, Virginia, and I'm studying biology, and this summer I was working at the Hawaiian Islands Humpback Whale Sanctuary along with Sasha under Alan Tom and the National Ocean Service. And so this summer I worked on an education activity guide for kids in the visitor center, and I was really interested in this project because I'm thinking about maybe marine science education, some kind of education pathway, and so I thought it'd be a good fit. And so a little bit of background about the sanctuary system, because I know when I first came in it was confusing. So it's actually only around 6 of the 8 main Hawaiian islands, and so I included these maps to show you. It's hard to see because I couldn't blow it up anymore, but the red lines are the boundaries of the sanctuary system, and so it's around Maui, Kauai, Lanai, Molokai, the island of Hawaii, and Oahu. And so we have this sanctuary system, but in order to inform the public about us and show them what we really do, there's also a visitor center, and that's in Kihei, Maui, where I was working. And it's really grown. There were 7,000 visitors in 2012, and this year, they don't have a total amount, but it's looking to even surpass that this year. And I think one of the reasons behind that is they had renovations to the buildings. So we have a whole new building, and it's really attracted a lot of visitors, especially during the humpback whale season in the winter. And so with those visitors comes tons of kids and students who come to learn more about the sanctuary and the animals and the plants that are in the system. And so the site really needed a way for the kids to understand and learn what was important to conserve and a little bit about the sanctuary. So I was in charge of putting together this activity book for them. And so this book is to be available online and also in the visitor center, and it was important for it to be online because a lot of people can't come all the way to Hawaii, but they want to learn more about the sanctuary system, and so they can just go online and download it, print it out, and their kids can do it. And I couldn't have done this without my mentors. They were really great and wonderful in supporting me and helping me whenever I had questions or anything. So my main mentor was Alan Tom, and then Nancy Doshbach and Carl Abraham also really helped me. And so when I first started out this project, I focused mostly on doing activities for middle school and high school elementary and middle school students, because that was most of the kids that were coming in and interested in doing these activities. And I focused mostly on the plants, animals, and places around the visitor center and Hawaii. And then I also had pages on the Hawaiian culture and on NOAA, which I'll explain later why that was important. Used a computer with Microsoft Publisher and a camera, Canon camera. Oops.
And so the first page of my book is just an introduction to the sanctuary, what we do, what it's about. And then I also introduce Kai the humpback whale, who guides the kids through the activity book and shows them the activities that they should do. And there's also a cultural aspect there because Kai means ocean in Hawaiian. And my next pages after that are a scavenger hunt for the kids to do. I thought that was important to include because a lot of times when the kids came in, I saw that they would go straight to the games. And the games are important, but there's no information really behind them. And I know as a kid I would probably do the same thing, but the scavenger hunt is kind of a game for them to find information on the displays and really read and absorb it. And then I also had a page about NOAA and the goals and missions and about the NOAA symbol because I found when people were coming to the visitor center, they didn't even know that the sanctuary was under NOAA or even what NOAA was. And so that was important for the kids to understand what we do. And then I have a fun activity for them to create their own symbol, which I thought was something creative they could do. And then I also had a page on the location of the 8 main Hawaiian islands. And that was important, especially for the kids that come over from the mainland, and they don't really understand where the Hawaiian Islands are in relation to where they're coming from and how far away they are from where they live. So this globe, you can see the circle around the Hawaiian Islands and then the North American continent, and it gives them a perspective of where the islands are. And then I have a page after that that also talks about what Chantal was talking about, the National Monument in the Northwestern Hawaiian Islands. And I included that because it's our sister sanctuary system. And my mentors, especially Alan, he was thinking that this book, or maybe even pages from this book, could go to other NOAA sites. And kids there at the visitor centers could do it and play with it. And then I have 6 pages on humpback whales because we are the humpback whale sanctuary. So there's coloring, matching, connect the dots, a crossword puzzle, and my favorite, which is an entanglement response program page. So a program at the sanctuary, not a lot of people know about. It's if you see a whale that's entangled in marine debris or marine gear, Ed Lyman's in charge of the program. He gets a call, and if they see one of those whales sighted, they go out and they try to disentangle the gear. And so this page shows the public what the steps are of disentangling that whale. The pictures are the steps, and then there's explanation next to it of what they're doing, and the kids have to match up the pictures with the explanation. And so it gives them a little background information on the program so they can understand it. And so why do I have 6 pages? Not only because we have a humpback whale sanctuary, but because that's our main goal, is to protect these humpback whales and their habitat. And so how do we do that? One of our main things is education and outreach, because if the public doesn't understand what we're doing and why it's important to have the sanctuary, then our goal is lost. And so we have that, and then we also do research and resource protection activities such as the disentanglement program. And then I also have pages on the Hawaiian animals and the plants around the sanctuary visitor center and the site. A lot of these animals I included because they're either under the Endangered Species Act or the Marine Mammal Protection Act, and so there are rules and regulations for getting close to these animals, and a lot of times people don't know about them or don't understand them. And I mean, I've even seen in action when we were snorkeling, Sasha and I. There was a green sea turtle on the shallow end of the beach, and there were 6 people crowded around it, and it couldn't go anywhere because people were just watching it. And there are the rules against getting so close and following it and harassing these animals and disturbing them. And so these pages just let the kids know that it's good to look but not touch and get too close and stress the animals out. And then I also had a page on the Hawaiian plants that are around the visitor center. The kids have a picture and some little background information on the plants, and they can go out and identify the plant around the site. And then, so I included a couple pages on Hawaiian culture, mainly about the Oahua'a concept, which means from mountain to sea. And in ancient Hawaii, they had tracts of land that were split up on the island, and there would be a family or a group of people that would be in charge of taking care of this tract of land, and it would literally go from the mountains to the sea. And so as part of the sanctuary system, a lot of people think we're just here to protect the waters, but it's important for the public to know that we also are concerned about the mountains, because what happens in the mountains trickles down and goes into the waters. And then as Sasha was talking about earlier, the Ko'i'i, Loko'i'a, the Hawaiian fish pond is located behind the visitor center. And so that's a historic landmark and a big part of Hawaiian culture, so that was important to include in the book so the students can get a sense of what the history was behind the fish pond, what it does, and why it's important. And then I have a final word search page. It kind of ties everything together and has places, animals, and plants that I talked about earlier on in the activity book. Oh, and then I also wanted to take a brief moment and talk about additional projects I did. Sasha and I had the great opportunity. We were really lucky to go to the Ka'alave Island, which is, I don't know how much information you guys have on it, but it's mostly uninhabited, and that's because the U.S. government used it as a bombing range. And so there's a lot of ordinances and bombs that are on the island, and they did do a cleanup, but there's still a lot that's left there. And so as you can see in that picture there, it's mostly red dirt, and there's hardly any vegetation. And so the volunteer program is in place to have people go out and try to restore the island. And because we can't dig, because of the ordinances that might be there that could explode, we have ways of trying to collect dirt and soil. And so it's funny when you go out there, you just see there's ingenious ways of trying to collect dirt that just blows across the island. But the guy who's in charge of the program has like sheets around logs and like all these crazy things you see out there to try to collect the soil. So what our mission was when we went out there was to put rocks down with mulch. And so when the wind blows, that would collect the dirt, and then instead of digging, they could eventually plant seeds. And so there would be vegetation so they could help restore some of that lost vegetation. And then I also helped as an educator for high school and middle school groups that came, taught a little bit about seaweed, and then also volunteer in the visitor center. And so when I leave, I'm going to leave it in an edible form. So that was especially important because they're looking to change the displays in the future. So like the visitor scavenger hunt that I have, that would no longer, it would be outdated because those are mostly using display. So if they change the displays in the future, they, instead of doing a whole new activity book, they can just change the scavenger hunt part of it. And so, and then as I was saying earlier, it could be used at other Hawaiian NOAA locations. So completed book, and after the DC conference, it should be available online and for students at the Visitor Center. And I was able to give the book to a couple kids in the Visitor Center, and I have quotes that it was amazing and awesome. So, so I'd really like to thank my mentors. They were great. And then also Patty Miller, who's the education coordinator on Oahu here. I would love to have her on Maui. She would have been a great help. But we were able to call back and forth, email back and forth, and she gave me some great feedback on the book. And then also the sanctuary staff who are amazing. Joe Carrier, who is the NOAA Corps officer on the site, was the one that facilitated the Ka'alave trip for Sasha and I. So that was really great. And then everyone else has been really helpful in giving me feedback on the book. And then Sasha helped me with some of the photos. So thank you, everyone. Does anyone have any questions? Yes.
First, I just want to say I think this is a really cool project.
Oh, thank you.
I think it's really important too. I worked for 2 summers at the Stella in Bank National Marine Sanctuary.
Oh, okay. Yeah.
I did public outreach and whale watch tours up there, and we had something similar. We had like an activity for kids, and it really was very effective, and the kids really enjoyed it, and it got a lot of the information out there. But we found that it didn't really do much for parents.
Yeah.
So I was wondering what you maybe thought might be some really good steps to also kind of expand this information out just to the kids, and also, I mean, well, it's really important. It's a really effective way to get kids interested and get the information out. What about maybe some of the other visitors?
Yeah. As far as our older visitors, that really is a problem. We don't really have many events, and like we have a sanctuary classic that's coming up that maybe would be helpful in getting out the information because the parents are coming with their kids and fishing in the fish pond, and so that gives them some of the culture aspect, and the visitor center will be open so they can come in there. But I think one of my main things for the adults is the displays in the visitor center, I didn't find to be great for adults. There's a lot of great information for kids, but it's just mainly there's like a little bit of information on humpback whales and a lot of information on sea turtles, and that's it. And as an adult coming in, I think I would want to learn about other things, not only in the sanctuary site, but around Hawaii. And I think hopefully in the future when they change the displays, that will help. I don't know. I think because of lack of funding, that's one of the main problems. But yeah, did you have any ideas for like adults in the future? No. That's the only thing I could think of. Yeah, I don't know. But yeah, it's a big lack of information there for the adults. Yeah.
I was just curious how you created the black and white illustrations.
Yeah, so I'm not a very good artist, so I didn't create those. I can do like layout and be creative that way, so I think that's why I was picked. But those are actually done by a Hawaiian artist. So yeah.
Have you done projects like this before where you were putting together a book like this? It seems very inclusive and well laid out, and just wondering where the experience comes from.
I was actually a theater editor before, so maybe that's a part of it because I did a lot of layout. So I don't know. But thanks, I really love the feedback from you guys because I know a lot of it's just it's all science, and I find that really interesting too. Of course, on biology, but this is a different aspect, so I didn't think many people would be interested in it because it's more education. Yeah.
Other questions for Erica?
Is there a way? I mean, I couldn't get through all of the activities to see, what the kind of outfit was, but like for the NOAA logo and some of the other ones where they have to draw something or do something, is there a mechanism for them to share? Like, can they submit it online and there might be some gallery?
Where they could post what they drew.
Is there any sort of way for them to give feedback as to what they did or came up with?
No, there's not. That's a great idea. I can ask my mentors about that. Maybe make that a possibility.
Especially if classes did it together or something.
Yeah, or maybe they could like take pictures of it and post it online. That's a great idea.
Yeah. Just actually stemming off of that, when I was a kid, we'd go to national parks. When we got an activity book, at the end we would like show it to the park rangers, and then they would either like stamp it or something to show, oh, you're now like a little park ranger.
Yeah.
I mean that they would ever do that for here, like, oh.
Yeah, they have like tattoos and little prizes they can give out, so maybe that could be something they could do. I know for the scavenger hunt, in order to get the right answers, they have to go to a volunteer and show it to them, and the volunteer will tell them the feedback on what's right and wrong. So maybe after that they can go, maybe a little stamp on it. I don't know. Yeah, that's a good idea too. Any other questions?
What about
Thanks, Sarah.
Did she say something? Oh, yeah.
Okay. Since Alan's not here, if you want to just talk about what you're up to next.
I'm unsure about my future. I'm sure a lot of you guys are too. I don't know, maybe education. I worked in a genetics research lab last summer, and I found that wasn't really my love. So maybe not research, but maybe some kind of marine policy, marine education, outreach, something like that. I'm sure. Yeah. Thank you.
Okay. Next up, we have Mariana Alvarez. She's been working in the Protected Species Division with us at the Science Center. Her mentor Charles is not here, but I'm going to be looking to Kia or Liz to say some nice words about her at the end. What's up? She's with us from the Maine Maritime Academy.
Hello. Thank you guys for being here. My name is Mariana Alvarez, and I studied at Maine Maritime Academy. This is part of my senior research project, and it was done with the Hawaiian Monk Seal Research Program under Dr. Charles Lennon with the help of many of the people from the program that are here as well. The purpose of this project was really to look at the data that we have on the main Hawaiian Islands and find indications or indicators of the health and status, the success, and even some of the threats that the monk seal population faces here on the islands. And I was doing that looking specifically at the puff growth of weaning due to the fact that it is the indicator for the mother's success. One of the biggest questions that we had was whether or not we could even look at this data and find answers from it. And we hypothesized that there was going to be a temporal decline in puff sizes at weaning here on the main Hawaiian The Hawaiian monk seal is found throughout the entire archipelago, and it is declining. The population is declining at a rate of 4% per year, and we have approximately 1,100 individuals. However, the difference is that the main Hawaiian Islands, we have estimated to have 150 to 200 individuals, and it is growing 6 to 7% per year. So that difference gives us a lot of data and a lot of different ways to compare the two subpopulations. Well, there's no indication that the population here on the main Hawaiian Islands is reaching any sort of carrying capacity. The distribution is mostly towards the northern part of the main Hawaiian Islands, such as Niihau, Kauai. And so we wanted to see if we were going to find differences in girth sizes over the main Hawaiian Islands, which could indicate some sort of resource limitation or that the animals were reaching a carrying capacity. So the data was collected with a collaboration of the public, volunteer groups, partner agencies, as well as scientists on the populated main Hawaiian Islands. And it comprised data from 1988 through June 2013. And it was analyzed using R and SPSS in generalized additive models. Those are the variables that we looked at in the model that were specific to pup girth at weaning. And I want to point out post-weaning days because pinniped pups start losing weight and girth as soon as they're weaned. So we wanted to take that into account. And something else that I wanted to emphasize is that we had two different samples. We had what we call the dirty samples, the dirty data set, which included all of the animals with the mothers' ages, which were both known mothers, which we tracked since birth, as well as minimum age mothers. And then we had the clean sample, which was vastly reduced, but it only included pups whose mother's age we knew. All the models were then compared using a case information criteria to tell us which variables really explain the variation in girths. So this is a little overwhelming, and it is the model results for the dirty data set. And the predominant model that explained the variation is in bold, and it tells us that year, female age, of course the post-weaning days, and the pup sequence were the variables that really explain the variation in girth. But the second model was also had almost equal weight in explaining the variation. The take-home message from all the models that we found was that there was a temporal decline, and the graphs are really able to show us this. This is the output models for the variables from the top model, and I don't want you guys focusing on the y-axis, but just on the shape of the graph. So there was a temporal decline over time, and it plateaued towards the last 10 years, which is what we were sort of expecting. And female age was an interesting result, where the sizes declined with age, which is a great indication of senescence or the reaching of maturity, which is something that's found in other mammals, birds, and a lot of different pinniped species. Post-weaning days was also to be expected since, like I said, they start losing weight and girth as soon as they're weaned. And pup sequence was also really interesting incline with mothers that have more experience yielding bigger and bigger pups. Now we looked at the clean data set, and we had a lot more models because there was no single model that really explained what was going on with the data. And that really was a factor of the sample size. We didn't have a lot of pups. There's only been 139 pups overall born in the main Hawaiian Islands. So just looking at the known age mothers really brought that number down. The take-home message from this, which was contrary to the dirty data or all the data, was that there was no temporal decline in sizes. However, female age, from the models you see, is the predominant variable that explains the variation. So while the year does show a type of increase, it was not significant. It's really driven by the demographics for the female age, which you see is a very clean bell curve, with pups born of younger mothers having small pups peaking at between 10 to 12 years and then starting to decline, which backs up a lot of data from other pinnipeds, animals, and birds that show that older females have smaller pups or reduced survival in their offspring. Post-weaning days as well as pup sequence were to be expected, with pup sequence having a lower significance than on the direct data, with an increase in girth sizes until up to 4 pups that they have, and then it just plateaus, which is also an indication more of the female age rather than the pup sequence itself. So just to bring it all together, there was no temporal decrease in size observed yet. However, the data really is concentrated towards the last decade, so this is really just a preliminary result. We did find there was a decrease in size at weaning with increasing mother's age, which, like I said, is an indication of senescence, and it supports a lot of data which we found here on with the Hawaiian monk seals as well as other species. And one of the greatest things towards a management standpoint was that there was no indication that the Hawaiian monk seal here on the main Hawaiian Islands is reaching any sort of carrying capacity. There was no indication that there was a difference in sizes over the islands, which really sets us on track for the recovery plan of reaching about 500 to 600 individuals. So we're right on track for the population to keep growing and become a sustainable species and population, which is really good for the program as well as for the science that has been done. One of the biggest things that this program brought was really opening a Pandora's box of the projects that could be done with this data set, looking at other variables and that we haven't previously thought of before, such as are females energetically exhausted from having pups year after year, or if there are benefits from skipping a year between pups. There's also the question of foraging strategy, how it differs between the islands, if it differs or if it actually makes a difference at all. And one thing that hasn't been explored at all were paternity. We don't have a paternity test for these animals, and that is a big variable because half the genetic data comes from the father, and we don't have a way of tracking that or figuring out how big of an impact it has. The biggest thing that should be followed up in 5 to 10 years is just continually gathering the data as well as running these analyses again at least 5 years when all the data will be compromised of animals of known mothers, that way we can reduce the effect of demographics or age and really focus on if there is a change over time. I would like to I would like to acknowledge the Hawaiian Monk Seal Research Program as well as my mentors, specifically Charles Litting. Liz has also been a big help, and Sean, and Noah for giving me the opportunity to work here, as well as the Pacific Islands Fisheries Science Center.
Any questions? I have a question.
Yes.
The dome-shaped GAM function of female age was really exciting. Everyone that uses the GAM is always looking for that dome-shaped function to pop out as justification for using the GAM, which many other approaches won't pick up on. Does that match the known information on reproductive performance, demographics? And
yes, that was actually something that I learned a lot about was life history theories and reproductive theories, and it was right on par with everything that was going on from other pinnipeds, mammals, and birds, where reproductive performance in previous studies had been found to decrease over age as well as sizes and clutch sizes for birds. And it really made it so that this species that doesn't have a social structure, a real social structure, which are isolated so geographically, still follow with those theories and rules. So it just brings everything together. Yes?
Yeah, I just noticed that you had pup sex as one of the factors in one of the models. I was just curious if there was any difference between.
Interestingly enough, like I said, this species doesn't have a true social structure. The males are found to be smaller in size than the females, which was significant of the fact that it's the females that are driving the reproductive structure more so than the males. So it was something that we didn't expect.
Do you consider the condition, like body condition of the mothers on the pup skirt?
No, that's one of the things that just was another variable that was brought up for future study. We don't actually have a way of measuring the mother's size, the mother's girth, which really is one of the biggest variables for pup girth. But we took that into account as age. I did a lot of reading on other studies that actually took the weight of the females, and they showed that using the age as a proxy was a good way of taking that into account. Yes.
Gives you the point about whether there's what the benefits are to skipping a year. I missed if that was one of the factors you were looking at, or do we not have enough numbers to even...
I did look at it, and it was inputted into the GAMS. However, it only worsened the models, so there was really no true significance to that we found on this limited data to skipping a year. The variation in mean girths was just a little bit higher if they did skip a year, but it wasn't significant.
Thea, can I ask you to speak a little bit about Mari's time in the program and her project?
Well, Charles, we're sorry that you couldn't be here to hear all the presentations and to introduce Mari. One of the things we're interviewing for college scholars is we're very impressed with her conservation bit and it fit well with her program, which is both conservation and research. And during her short-term here, she's tagged it up and she's walked over 30 miles in the hot sun looking for seals to catch cameras to without very many injuries. But she's really tackled a big important data set, which had a lot of complexities to it. And we were just very happy with her work ethic and conservation bent, independence in thinking. Anyway, she has been a benefit to our program and has been a project that has raised a lot of other interesting questions that we hope to address later, and so we're really happy that she's here this time.
Yeah, for the 30 miles that I walked, we were tagging critter canning seals. I was part of this trip, and it was definitely an experience to remember. So it was really fun.
Thanks.
Thank you, guys.
Up next, we have Patrick Rex. He was an intern in the Station Research Program. With us in Science Center. His mentors were Yvonne Barkley and Alan Bayless here with us, and he's studying at UH Manila. So for that, go for it.
All right, let's wake it up. It's the afternoon. Let's get it going. I'm Patrick Rex. I'm going to be talking to you guys about vocalizations of Hawaiian false killer whales. I'm at University of Hawaii at Manoa. I'm going to be a senior this year, and I'm majoring in marine biology, and I'm HISO intern. So let's get into it. So what exactly is a false killer whale? Well, they're large agonocetes or toothed whales with sexual dimorphism. Males get to about 20 feet, females get to about 15, and the average weight is 1,500 pounds. They have one of the largest continuous ranges among cetaceans. They feed mainly on fish and cephalopods, and they form highly social groups with many subgroups. Now we're focused mainly on the false killer whales in Hawaii, and this is their range. And there are 3 genetically different stocks in Hawaii. As you can see, the yellow outlines the boundary of what we call the pelagic stock. The green outline is the main Hawaiian island stock, and the red outline is the northwestern Hawaiian island stock. It's important to note that the northwestern Hawaiian island stock, the boundary is still under debate. It's getting investigated, so it's not exactly solid. The insular or main Hawaiian island stock is also endangered with less than 200 individuals. It's also important to note that there is overlap in the stocks. All 3 actually overlap in Niihau and Molokai? Yeah. Kauai, sorry, yes, Kauai. And that makes identifying them by stock incredibly difficult. We also are interested in them because of their longline fishing interactions. We know that the pelagic stock is interacting with longline gear, and the bycatch of the longline fishing exceeds its sustainable levels. The northwestern Hawaiian Islands and the main Hawaiian Island stocks are unknown, but it has been debated as a possible explanation for the endangerment of the main Hawaiian Island stocks. So let's talk about the vocalizations of these animals. The reason why we're interested in them as well is because whistles are a main form of communication for the animals. They're also relatively easily collected via passive acoustic methods, which is towing an array behind a NOAA vessel. And the array acts basically as a giant microphone which collects all the cetacean noises. Now the red box, if you don't know, it circles a whistle on what we call a spectrogram. So when we find whales, we record it, run it through a program, and it spits out this. This just visualizes the whistles for us so we can analyze them. And the x-axis is time, and the y-axis is frequency, and that will be true for all the spectrograms you see in this presentation. Whistles are also important for false clear whales because they have a specific range that identifies them as false clear whales, usually between 1 and 16 kilohertz. As you can see here, the whistles are between 5 and 9. So the purpose of this research. Because of time constraints, I'm only working with the pelagic and northwestern Hawaiian Islands stocks, but the purpose is to evaluate the characteristics of the false clear whale stocks. So whether there are differences between the pelagic and northwestern Hawaiian Islands. And the future of this research is to incorporate that data into a classifier so we can identify the stocks by the whistles alone in real-time passive acoustic monitoring. And again, this is just the first step to analyze whether this is the right step to go into to create a classifier for these animals. So let's talk about collecting the actual whistles. I was lucky enough to be part of this process, and while I was able to go out at sea, the data we collected was not part of the data set. But I was aboard the Australian SETI for 30 days, acting as acoustician. Every day we'd go out and throw out the array and collect whistles from cetaceans. And every time we heard a false clear whale, we'd start recording, and that entire recording would last from the moment we heard those whistles until the moment the cetaceans left. And that's what we call a detection. We also had visual identification to confirm that, yes, these were false clear whales, just to make sure we weren't hearing strange things. I also learned that field work is incredibly hard. It's working from sun up to sundown, but it's incredibly rewarding and ultimately fun times. So the data set we have is 7 visually and genetically confirmed detections from the pelagic stock. Because of time constraints, I was only able to analyze 7 out of the 12, so there are 5 additional. And then the northwestern Hawaiian Island stocks, we have 5 visually and genetically confirmed detections. So whistle selection is incredibly important. So as I said, we ran the detections through a program, and that allows us to visualize the whistles. I went through all the detections and selected all the whistles of decent or better quality. Now this is because ultimately we want this classifier to catch each and every whistle made by these animals. There's an incredible wide variety of whistles these animals can make. So we don't want the classifier specifically looking for 1 or 2 whistle types. Also, because we have to take these whistles through another program, they have to be visualized. If we can't visualize it, we can't measure it. So it doesn't work. Through this program, I was also able to select each and every whistle, which assigned a number to the whistle, which then allowed me to select 50 random whistles from each detection, which allowed us to reduce bias. So this is just an example of the variation in whistles these animals can make. The top 2 are northwestern Hawaiian Island whistles, and the bottom 2 are pelagic whistles. And as you can see, that's just an example of the selection process. Each whistle has a box and a number associated with it. I just want to point out that although there is very visible difference in these variations, that's because I picked it out. And each detection can get as long as 5 hours. These are only 10 to 20 second clips. So I can see just in between each detection, there's a wide variety of whistles being made. And then this is just an example of how complex the detections can get when these animals are chatting away. So the total number of whistles gone through, for the pelagic, I went through 18,000 whistles from 7 detections, and whittled that down to 350 whistles individually measured. For northwestern Hawaiian Islands, I measured 10,000 whistles from 5 detections and measured 250. So the process of actually measuring the whistles, we ran the individually selected whistles through a program, and that allowed us to single out the whistle we wanted and then trace it. The tracing allowed us to submit that into the program, and the program then spit out 54 whistle measurements. These whistle measurements are ultimately what I went through and analyzed for differences between the 2 stocks. So I obviously can go through 54 measurements, time constraints, and also some of them didn't apply to false clear whales, such as steps. Some animals have steps on their whistles, false clear whales do not. So I'm just going to give you an example of one whistle and then the variables that we analyzed. One of them was the frequency mean, the frequency range, the duration or length of the whistle, the beginning frequency, the minimum frequency, which in this case is the same, but it's not always the same, the maximum frequency, and then the ending frequency. And so, to save some time, I'm going to just go through the duration analysis, because as I said, we went through all 7. And so the reason we went down to 7 is because some other literature chose those 7 to create their classifier, and we're following suit. And so let's get into the duration analysis. So the box and whisker plot on your right, or your left, just shows the range of the data. The black line is the median, and then the whiskers are just the range of the data. As you can see, for the Northwestern Hawaiian Islands, the range is much longer than the pelagic stock. The median is also much higher. Now, if you go to the other graph, you can see that the mean whistle duration is much higher for the false clear whale, or sorry, the Northwestern Hawaiian Island false clear whales than the pelagic false clear whales as well. We also took the data and ran it through a t-test, and the p-value was actually significant. It was less than 0.05. So our preliminary data shows that duration for Northwestern Hawaiian Islands is much longer than the pelagic stocks. I just want to mention that all of our data so far is preliminary. We're still going through this. So we did the same kind of data analysis with all of the variables. Now this is just an overview of what we've done so far. Each of the variables that have a little asterisk have been ran through a t-test, and they have been shown to be significant. So as I said, duration is longer for the Northwestern Hawaiian Island stock. The maximum frequency is higher for the Northwestern Hawaiian Island stock. The minimum frequency is higher. The ending frequency is higher. And then the frequency mean is higher for the Northwestern Hawaiian Island stock. The beginning frequency and the frequency range had no significance, and those ranges actually overlapped quite a bit. So overall, what we found so far is kind of really exciting, because there is a difference and that we can actually do something with this data. We can also conclude from preliminary data that there is a difference, and that the Northwestern Hawaiian Island stock is in general longer and higher in frequency than the pelagic stock. So in conclusion, yes, there are some differences, and analysis is ongoing. The next step is to take multivariate statistics to develop the classifier. So we ultimately want to know how duration and maybe maximum frequency are interacting, and then how we can classify that as Northwestern Hawaiian or pelagic stocks. The future of the research is utilizing the classifier that we make in real-time passive acoustic situations, and then also hopefully we can use that to analyze the logline situation with the endangerment of the animals. Using acoustic equipment, there are some projects that attach acoustic equipment to longline gear, and hopefully if false clear whales pass by, we can see which stock they're coming from. If you don't know, Hawaii is also home to the only false clear whale that's being used for research. And she's a beautiful animal, so I just want to show her off a little bit and show off her massive jaws and all that jazz. And just some quick acknowledgments. I want to thank Yvonne Barkley and Ali Bayless for making this a very fun and really rewarding experience. I want to thank the entire crew of the Oscar Elton SETI for a little bit of hazing, as you can see in the picture. You don't need any of that gear to fire an XBT, which is what I'm doing. So it's a little ridiculous. And I want to thank Jaimar and Piss for the amazing opportunity. I've enjoyed my time immensely, and it's exciting getting to the final results that we're going through right now. And thank you all. Take questions.
Questions for Patrick? Come on, this is fascinating.
No one's ever answered, why is it called false clear whale? Why don't they call it
I actually know that answer. It's
kind of more like a dolphin.
yes, it's classified what, dolphin? But it's a false killer whale because the skull structure is more like a killer whale than other dolphins. So that's why it's called a false killer whale.
You guys come up with a better name?
The radical dolphin.
Maybe that would solve their problems, rebrand them. Yeah, right. Stop calling them false, maybe they'll Did you have an acoustic background, or did you learn all of this while you were there?
Yeah, I learned all this kind of, especially on the cruise, on the road. So it was a crash course, but it really, I know I'm going to get that question, how long did each detection take? The first detection was around 10,000 whistles, and it took me a week and a half to go through. And then the last detection I did took maybe 2 or 3 hours. So it was a very steep learning curve, but it did pay off. I was able to go through the detections a lot quicker.
You mentioned that some of the whales have different shaped, I don't know if you call it curves, I guess, for the localization. But they usually, for example, I don't know, if a humpback went by, I'd imagine looks drastically different than with the false killer whale. So were they pretty easy to see the difference?
Yeah, actually, I mean, on the boat, what we were doing was we had the array out, and we were listening, and then we had a program that would just create spectrograms in real life. And so if we heard a whistle, it would visualize the whistle. And by the end of my time on the boat, I could tell you, hey, this is a false killer whale, or to a lesser extent, this is like a spinner or a striped, but those whistles get a little closer, so I couldn't differentiate them.
If you had some of those other ones, like spinner dolphins or whatever else, while you're doing that program, you kind of mark them as spinner dolphins?
Yeah, I mean, we in the program, but we would like write it down like that's a spinner dolphin. And so what we were doing on the boat is we had a few key species. So if we heard those, then we go into protocol. And for the false killer whales, we actually tagged 2 of them and tracked their movements. And so we heard them, went to protocol and all that jazz. Whereas the spinners, most of the time, we documented them, took pictures, and then went on our way. Yes.
You mentioned that with your detection of false killer whales, you also got visual and genetic confirmation. How did you get the genetic?
Yes. So again, on the cruises, we had small boat operations. So if we did hear a false killer whale and they're within a certain distance, I think our distance was sort of 3 nautical miles, then we would launch in a small boat. So 1 driver, 2 shooters, I guess, and then and then samplers. Sorry. I'm doing the citation program well here. 2 samplers, and then a recorder and an observer. And then we go on the boat and then try to get as close as possible. And then we had crossbows with specialized tips that would shoot into the animals, and that would take skin and blubber samples. And then I think we had some rifles that shot tags as well if we needed to. So that was a big part of the cruises, trying to get as much genetic and tagging as we could. And yes, that's how we got the genetic samples.
Any of these whistles compare with whistles from false killer whales in other parts of the world?
I mean, that's part of the project. We're trying to see, we're kind of just localizing it into the Hawaiian archipelago. But from the preliminary data, I'd say they're different. I mean, they're not going to be as different as like striped dolphins and false killer whales. But I would say my best guess is that there's probably some frequency differences and maybe duration differences, like we saw in the preliminary data. But the answer is I don't really know.
All right, Yvonne? For Allie? Yeah, I just want to say you can be very enthusiastic. We're hoping to find someone for this project because false killer whales are a major focus species for Allie and I in our research. So we knew this was going to be tedious work, and we needed the right person. And Patrick turned out to be, we were pleasantly surprised that he was definitely the right person for this work. And I wanted to point out that we first met him during our cruise prep and his finals. So it was chaotic and stressful for all of us to sort of be setting up for this internship and the cruise and finishing school for him. But it all turned out well, despite my apprehensions of how we not only had to train him for learning how to actually collect acoustic data, which he had no experience with, and it is a steep learning curve. But he did really well and also able to focus on his project as well at sea. So I just want to commend him for that because that was a lot of work and he did really well. So yeah, we're excited about these results, and his work is going to definitely help propel this project forward. and to other areas.
Awesome.
Thank you, Patrick.
Oh God, look at that picture.
All right, so for our last talk of the symposium this year, it's sort of fitting that we end with the Segue to the Future. Anna Campbell is going to be talking to us about her Hollings internship next year. She's here doing some pre-work for that internship, which she'll tell us about.
Okay, hi everybody. I'm Anna Campbell. I'm from Smith College and also Oregon, so opposite coasts and now a third coast. I'm actually not exactly talking about next summer because I have no idea what I'm going to be doing next summer yet. But I'm here doing a separate internship with NOAA. It's kind of a little bit similar to the Hollings program. So my school has a memorandum of understanding with NOAA where they place our environmental science and policy department places interns every summer around the country, and so I was lucky enough to be able to come out to Hawaii and help Doug out at Pacific Services Center with something called the Sentinel Site Program. So my title, after going through millions of brain science puns in my head, I settled on a bridge to the future because my role, I see it this summer, is kind of being a bridge between science, hard science, and management, and policy and application. So with that, yeah, I'm going to talk a little bit about Sentinel Site. So Sentinel Site is a relatively new initiative by NOAA, which its main mission is to corral coastal resources around the main theme of sea level rise. So sea level rise is kind of a temporary focus, and after, we're not sure exactly where the program is going to go, but in the future it might focus on other, like have a year or two focus on like ocean acidification and see how that goes. But right now, the first topic is sea level rise. And so right now there's 5 sites around the country. And the Hawaiian Islands site is a little bit unique in that it has 4 different locations around the Hawaiian Islands where everything else is kind of one bay or something. So that's an interesting challenge. And yeah, so these regional cooperatives are basically, in other areas of the country, the idea is to tie all the existing NOAA resources together and kind of localize them in one place, because right now, NOAA might, I mean, to the outsider, might seem like it has, you know, a unified mission and vision, but out here it's like we work in separate offices. A lot of times we don't know what the person next to us exactly is focusing on. So we wanted to, Sentinel Site is to kind of centralize everything. And so, the concept of Sentinel Site is dynamic depending on the regional needs. So the idea is to localize this idea of how is sea level rise going to impact this place, these communities in this place, and how can we help with that, and how can we use all of NOAA's resources in the area to help with that. So, as I mentioned, there's 4 sites within the Hawaii Sentinel Site. One is the Ahupua'a of Haida here on Oahu. One is a section of the Kuna Coast on the Big Island, and 2 are up in the Papahanaumokuakea National Monument at French Figure Shoals and Midway Atoll. And so there's a huge range of human influence, right? So in Haida, and I mean this is the most densely populated island, there's a lot of human stressors going on. Haida's main focus is a big restoration project of the whole ridge to reef system. Whereas up in the monument, it's pretty pristine. And so that's kind of a unique feature of the Hawaii Sentinel Site, is that we can see how climate change in general is affecting these different regions differently. We are unique in that this is a very unique place, right? We all know, geographically, physically, and culturally. So it's all the more important to have something that really focuses on the individuals and the individual challenges here. Kind of the Sentinel and Sentinel Site is just in general, since this is kind of a new initiative, it'll be nice to have models for other management challenges on all different scales. So ideally, Hawaii, we're actually kind of farther along than some of the other Sentinel sites, and so we hope to provide kind of a model of how this mandate can work and actually be useful in other places. And in general, the Sentinel Site program can hopefully be kind of little snapshots of like what effective management looks like. So how I got involved, I mentioned Smith College. I'm here, and I am a Holland Scholar next year. So hopefully I can find some way to tie this all together. I hope to come back out to this region next year and continue or kind of branch off from this work. So my project, so overall objective, is since the Sentinel Site here in Hawaii is kind of still getting on its feet, my goal is to just kind of create a huge overview, and I'm a very visual person, so a map is kind of my main product of who's doing what where, and who needs what. All focused on this idea of sea level rise. So I'm making a huge map of all of the sites and kind of finding out and talking to researchers, talking to stakeholders, finding out who needs to know things based on salinity, based on temperature, based on things that are going to change with sea level rise, and then finding out who's doing research in those areas and hopefully linking them up. So one of my kind of sub and parallel projects is I'm making a project matrix of all of the sea level rise kind of viewers and projects going on in the Hawaiian Islands. So started with the Axis, what's Axis? Pacific Climate Information Systems, yes. Directory, that a great directory on the webpage. So we kind of narrowed it down to things that directly had to do with sea level rise and directly had to do with the Hawaiian Islands because they deal with the whole Pacific. So we narrowed it down from there. We're kind of contacting people to see what their projects are and who their audiences are kind of and what their outputs are. And hopefully we can kind of display that visually so everybody knows where we might have gaps or where we have kind of parallel work going on.
Nice.
Yeah, so I'm having an awesome summer. I don't know about you guys. Hey, we're doing a lot of work in Haiti specifically. So you guys might know they have a huge network of restoration projects going on in that area. And so they are a big part of my map is kind of mapping who those nonprofits, those stakeholders, those community groups are, and what they're doing relative to each other. Bridging the gap, my mission between management and scientists. And we discussed recently the possibility of kind of an outreach video type thing, because I'm really interested in video and kind of the imaging side of things and outreach, so that might happen maybe next summer. Our focus on the Big Island right now is Inky-line pools. So we had a meeting the other day with Lisa Merrick, who is one of the researchers doing a lot of different projects over there on focusing on Inky-line pools, and we talked to her about who's managing these pools and what are they managing for. So we found out it's a huge mix of public and private, and depending on where they are. And invasive fish are a huge problem. Salinity is kind of a rising concern with sea level rise. So again, we're hoping to dive into that and bridge the gap between scientists and managers by finding out what needs to be known for these managers and who can supply them with that information. And so Sentinel Site itself doesn't have funding, but our mission is kind of a good thing because we don't have, a lot of times when you have money, you have strings attached to it, right? So ideally we can just talk to people on an individual level about what they need and get a really solid picture of what people need, and then we have that handy link into the federal government to be like, okay, you know, there's money here, like, let's link you up. A sampling of successes so far. We have provided some historical aerial imagery, which was all georeferenced and stitched together, the tiles from 1928 and 1954 to a variety of stakeholders. It was of the Haiti area, and it showed the Pai, the fish pond, and all the ancient taro patches. And so a lot of people found that really cool. I mean, it's really cool to look at historical aerial imagery, like kind of cool and helpful, and hopefully it will help people with outreach and kind of getting a picture of the area as a whole. We held a meeting of our most recent meeting of Sentinel Site program managers. So we're still kind of studying it and seeing how we can be of the most help to people involved and people who are leading the management of these areas. We presented at the Hawaii Conservation Conference, which is awesome. It was really fun. And we're continuing to be involved with the community groups. And I'm just kind of plotting through our data bank of GIS information and all the, because we have a lot of spatial information about all of these sites and we're trying to get it organized and stuff. So hopefully we can connect people with it better. Okay, I could not fit everything awesome else that I've gotten to do on this slide, so pardon the really busyness of it, but so far I've gotten an awesome amount of GIS training. I'm so much more familiar with the software than I was, and ArcGIS Online, as part of the conference, I got an extra training on that, so that was really cool. If I have time, I was trained in something called Canvas, which is known as visualization software, and so if I have time, I'm going to be folded in a little bit to the this project. We have a sea level rise viewer on our website, and you guys can play with it. A piece of it that we don't have yet is we want to have landmarks on each of the islands and show what it looks like at varying levels of inundation. So I might be able to help with kind of building that. I drafted a call for proposals, which I've never done before. I'm a bio major, so all of this office stuff is new to me, but it's been really, really valuable. And I've gotten to go out with the Nature Conservancy, has 3 fellows who are doing a variety of stuff in Kaneohe Bay and other places. I've gotten to accompany them with some of their field work, which is fun. Design thinking workshop was just kind of something in our office, which I thought was exciting. And yeah, more stuff for TNC. I did media training, which was really sweet. And then possibly in the future, again, if I have time, I have a lot on my plate, but hopefully I might get some experience in grant proposal drafting, which, you know, new science people, I don't know, probably it's a good skill to have, right? And GIS field work this week, our geospatial team is going out, so I might be able to come to them. And some elevation data coverage analysis is goes back to going through a GIS data bank and figuring out what we have, organizing it. So yeah, in conclusion, I am a Hollings intern for sale next year. So ideally, depending on where the rest of this, I have about a month left where the rest of this project takes me, I can find somewhere to fit in next summer and make the most of my time here. And a lot of things, I could just spend 10 minutes thanking everybody, but Smith College, our ES&T department is great. My advisor is someone who turned me on to all this and explained it and really got me here. And everyone at OPSC is wonderful. I love them all, but most especially Doug Harper, who is great. Thank you. Maybe a few words from Doug.
Well, first off, thanks a ton to Anna for coming here. There's part of me that kind of wants to sandbag my compliments about her so that next year she has no other options but to come back and help me. But, in all honesty, she's been absolutely fantastic. As you saw from the PowerPoint, we've kind of thrown 1,001 different things at her. The Sentinel Site program covers a lot of different things, and there isn't really a designated staff. There's no funding. So when she came, it was kind of like just pushing a bunch of stuff under her plate and saying good luck. And she's done a fantastic job. She's been enthusiastic about everything. She hasn't had to have much training, which has been fantastic. You know, it's not one where I've had to hold her hand through all of this. So it's literally been giving her the work, and she takes it and runs. And so she's really kind of provided a boost to the program and helping it move forward and move ahead. And the work she's done, she's halfway through her internship right now. So the work when she completes this is really going to help us move forward and answer a lot of these management and science issues that we've been having to deal with. So a big mahalo to her, and despite my hopefulness of sandbagging her, I would highly recommend her to anyone who's looking for a project next year. She's been fantastic.
Okay, we're at the end. I'm going to ask Sam and Jeff if they have any remarks to say. First, I want to do a quick thank you to the moderators, Aaron. Thanks for doing this. Molly for doing the previous one. thanks to Marty back there patiently doing the video for us. We're going to have a very cool video recording merging what's on from that camera and what GoToMeeting's been recording on the screen. So stay tuned for that, and it should be a very cool thing to watch. Giving oral presentations is valuable for us as scientists, and I think having that video will be great. You can kind of rewatch it. I hate watching myself give a talk, but I think it's very important to do that, and we've seen so many brilliant scientific careers derailed by people that can give a very good talk. And what's sad about that is it's totally avoidable. Anybody can get over their fears, phobias, and quirks and give a good talk. Well, maybe there was one guy that was not able to do that, but it's not we're not genetically programmed to give a bad talk. Anybody can give a good talk, and it's something you really should strive to do because it'll help your careers out a lot. It's not always what you know, but how well you could sell it. And it's also not what you know, but who you know. And we gave a lot of breaks during the symposium and a very long lunch break. Hopefully you've all been able to network and meet some of your peers and meet some of the scientists here. I was going to say exchange business cards, but looking at the age of this group, I'm going to say become friends on Facebook, Instagram, LinkedIn, Twitter, Tumblr, whatever your weapon is. Feel free to network. I'm a Facebooker, and I don't turn down any requests for friends, by the way. So I think all the previous interns that have passed through have friends with. So feel free to friend me. I'll say yes. Let's see. How about a round of applause for the whole day, all the presenters, mentors, and moderators. Jeff, would you like to say anything now that we're near the end?
Well, first of all, I want to thank Don. I think we're all Don single-handedly put together the program and made lots of contacts, and several other scholars aren't on Oahu, and so he made those contacts. And, as he said in the past, it had been exclusively kind of a PIPS thing, just in the Science Center, but he's expanded it. And I think that's an excellent idea because it sort of encompasses all of NOAA, and it brings all the scholars here, all the students here in one place where they can network. What I saw here today is very encouraging as for the future. For if all of the scholars and all of the centers in NOAA are like you, then that's exceptional. So congratulations to all of you for the really excellent presentations, the good work that you're doing. And like I said earlier, if any of you in the future are looking forward to employment, JIMAR is one of the means by which the center conducts its work. So keep your eye on the RCUH, the Research Corporation of the University of Hawaii. Keep your eyes on their webpage, and maybe there may be opportunities for you in the future. Keep in touch with your mentor. You're going to rely on them for references. And again, thanks, Tom.
Thanks, Jeff. And I'd like to say a few words before Sam talks. I forgot to mention, if you came in late, please sign in. We'd like to know who came in. If you haven't signed in yet, please sign in. Sam?
I'll be real brief. Just echo what Don said. Don, the presentations were uniformly excellent, and the kind of thing that we would like to eventually convince some of our staff to be able to do. But at the same time, it's not just a question of presentation. It's a question of really learning both academically and experientially. And obviously, these internships provide you an interim step towards that. And those steps have to continue if you're going to be successful, and if we're going to harvest the fruits of your labor. So keep on going, and however whatever that direction goes for you, good luck. You've got a really good start. So mahalo.
Okay, thanks everybody for coming. That's it. Feel free to hang out in the room and shout if you want. You don't have to be out here.